in Nigeria. I'm also a data scientist. So I'm going to be the instructor for the 2-day mini course that we're having on disease surveillance and outbreak analytics with R, which is hosted by Business Data Laboratory in collaboration with the Abuja R user community. So this course, who is it designed for? Well, the course is designed for public health professionals. If you are a public health practitioner, this course is designed for you. You're also an epidemiology worker or studying epidemiology at graduate level, then this course is also designed for you. Is also a disease surveillance officer, then this course is designed for you. Also monitor and evaluation officers and health data analysts, researchers and postgraduate students, NGO and health program staff. So you don't actually need any prior experience. I'm just going to take you just have some crash. I'll just give some crash knowledge, which is sufficient for you to be able to pick up from there. R is very interesting and it's easy. It's not that difficult. So you don't need a prior experience for you to be able to follow through or follow along. So what are you going to be going with at the end of the course? So the course is actually designed in 2 days. So today's session, which is day 1, which is 10 to 12, and tomorrow's session, which is 1:30 to 3:30. God's willing. So in day 1, you're going to learn about some of the basics of R and also about R Studio. For those of you that are still new, that are new to it, and those that are familiar with it, it's just more or less going to be like a revision. And also, you are going to explore an unfamiliar data set, the disease surveillance data, which is actually messy because that's what we expect in real life. So we are going to be seeing consistent texts, just the way like a real life data is going to look like. Then messy/impossible ages, also dates in multiple formats. Maybe someone is writing month, day, year. Another recording, you're going to be seeing year, month, day. So different kind of formats. How can you handle these kind of formats? And also duplicate records that duplicate. Some can appear twice, the same information, but appearing twice. So you need to deal with such records. So I'm going to be looking at some of these in day 1. This is what I'm going to be talking about in day 1. So what's our scenario? What's our case study? What are we actually looking at? So we're looking at a suspected acute watery diarrhea outbreak that has been reported in Ogun North local government area. So a raw line list has just arrived from the field data collection tool. Before anyone can analyze it, you need to clean it, just like you were expecting in real life. So in real life, you hardly get a clean data. You are mostly going to be dealing with a messy data. So I'm going to use the simulated line lists. So this is the data we're going to be using throughout the course, which is going to be shared with you people. I think it has already even been shared with you guys. So we are going to be dealing with the data, then the roadmap. So day 1, I've already talked about what we're going to cover in day 1. I've talked of what we'll cover in day 1. While day 2, we are going to be looking at descriptive tables, epidemic curves, and also outbreak measures. That will be for day 2. So day 2 is going to be, day 1 is just more or less like we're cleaning. Day 2 now becomes where we now answer the questions we are trying to solve. So what questions are we trying to solve? I hope I'm being heard.
Yes, we can hear you, sir.
Yes,
So,
please.
yes.
Okay. Okay. So that's it. So R Studio and R Studio basics. So a lot of us been hearing R Studio. What are they? What is it? So R is actually the programming language. It's the engine that does the calculation. So R is a programming language, but it is designed for by statisticians for statisticians, whereby you can conduct statistical analysis, data science, machine learning inside R. You can do a lot of things with R because it's a programming language. Why we have R Studio? So R Studio is like the cockpit. So R is more or less like the engine. So why R? You can use R itself without having R Studio, but that is more or less like an archaic way of using it. You are not going to enjoy the features that R have to offer. So because some advanced features have been offered through R Studio. So R is more like the engine, while R Studio is just like the body parts that you now use, the way the engine now operates on. So we also have what we call packages. So R comes just like when you have a truck. When you have a truck, it comes just as a truck. But for it to be able to carry loads, you need to attach a body to it. So those body is what we call packages in R. So these bodies that you're attaching to it, because the truck on its own, yes, the truck can transport maybe 2 or 3 people inside from point A to point B. But if you have loads to carry, what do you do? So you need to attach a body. And that body, it depends on the size of the load you're trying to carry. Are you carrying a small load? You can attach a small body to the truck. Are you carrying a bigger load? You attach a bigger body to the truck. Each has its purpose. If you are carrying petrol, then you attach a petrol tank to the truck so that I can be able to carry that particular product that I'm trying to carry. So that's the work of packages also in R. Packages allows you to be able to use a lot of advanced features which R does not offer. So you can do some things with R, but when it comes to some kind of scenarios, you need to use some of these packages to be able to enjoy R or use it to the maximum capacity. So that is where we are packaged. And the most popular packages we have in R, we have tidyverse and we have ggplot2. So I'm going to be going through them later on. Tidyverse and ggplot2, these are some of the popular packages we have. You also learn how you can install them inside your R. So we have the R Studio layout. So I'm going to be going to R Studio layout. And so I should expect, hope nobody have a challenge installing R or R Studio. If you have, you can let us know. So we have a way to help you out. If you have any challenge, please let us know. We can have a way to help you out. So I'm going to be going to the R Studio. So this is how R Studio looks like. This place might look different on you if you are using a Windows PC. So it might actually look different, but you still have the same things here. I think there should be a tab you will press, all of this should be able to come out. You have your file, you have your edits, you have code, you have view, you have plots, you have session, you have build, you have debug, you have profile, you have tools. So we're just going to be looking at just few of them, because some of them might not even need them, or maybe you need them for advanced use cases. So you have the file. So under the file, you see some of these options that you have. So one thing one thing with R is that if you want to work in R, you can just decide to create a new file like this. Just new file, and you start. But there's a problem with this. The issue now is that you have not bundled your work. You might be working with 5 data sets. You might be working with other scripts. You might be having PDFs you want to get information from. By just creating a file, you have created a file directly into your local directory. That's your PC directory. How can you make it arrange? So that's why we have what we call projects. So you want to execute a project. It's a way of organizing your work. You are working on a particular disease surveillance. Then you create projects. You are working on your master's thesis or dissertation. You create a project for that. Everything is bundled or dependent on each other inside the project. So anything that you need for that project is inside that particular project. So project is a special folder. A project is just a folder, but a special R folder. A special R folder in the sense that it allows you to be able to organize your work and put them into one place, and even share it with others. You can share your project, and the person that will work on your project to check it for you, or maybe to add or collaborate with you, will also have the same thing. You can even push it to an online repository. It makes it easy. So if you want to start a work in R, you create a project. You hardly create a file. You only create a file after creating a project. That is only when you create a file. So currently now, this is a project. So I'm just going to open another window so that I'm going to show us. So this is a new R Studio window. This is a new R Studio window, as you can see currently here. If you want to create a project, you go to File, you click on New Project. you have three options here. New directory. That means you want to create a brand new folder to create your project inside. This is what we call new directory. You can click on here, and you have different kind of R projects. I told you a project is a special kind of R folder. And this R folder can be in different formats. We have what we call a Shiny application. If you are creating that, this is going to give you a boilerplate, just like a structure or a template for a Shiny application. We have Quarto projects, we have Quarto websites, we have Quarto blog, and we also have Quarto book. And we also have Quarto manuscripts. So all these are various kind of what are projects. So this is if you are creating a new project. But if you just want to start from scratch, you don't need any of these templates, you just click on new projects. So you can see it now. You type your directory name. I can just say my first project. And this is going to be the folder where I'm going to save it. So you can see if I click on browse, I can select the folder, either my documents or maybe my downloads. So the directory name is going to be my first project, and your folder name is going to be this. Then you create your project. So before we create it now, you have what's called existing directory. So this one is if you already have a folder. You are already working on one folder. You don't want to go and create a new folder. You can create the R project or convert that particular folder into an R project. What makes a folder a R project is a particular diamond sign I'm going to be showing you now. I think if we go to the files, documents, you can see this particular diamond sign, .R project. This is what makes a folder a R project. Once you have this in a folder or you see a folder with this, that means that particular folder is an R project. If you don't see this, then it's not an R project. You might be able to open the folder maybe in R, but it is not an R project. So you need to see this design. It looks like a diamond. You see R on it. So that is what makes it a project. So that is for existing directory. You already have a folder. Then we have version control. So version control. Version control is you have already created a repository on GitHub. So if you are familiar with GitHub, so you just click on Git. Git and Subversion are two different kind of version control systems. So if you just click on Git, you can put your repository URL in this place and also your project directory name in that particular place. So once you do that, then it's going to pull it for you from Git. In fact, you might not even need to put the name. Once you put the repository URL, it's going to automatically detect the name from GitHub. So, and once you put it there, then you can now create your project. It's not necessarily GitHub. It can even be Gitpod. So, or it can even be so any other version control systems that uses Git. So once you put the repository URL here, you should be able to get the project directory name in this place. So this is it for creating a R project. So once I go back to my new directory now, new project, my first project. So if you want to create a Git repository, if you don't have one, you can check on this. If you don't want to do that, then you leave it. But me, the best approach that is much more easier is for you to create it online and use version control to create your Git repository. So once you have this, you don't need to be storing your file in Google Drive, because I'm very sure a lot of us are familiar with OneDrive or Dropbox. When we are working on a particular project, we'll be saving it in the drive. So once you are working with things that deals with coding or programming, it's best to just store the file on GitHub repository or any other particular online repository you have that uses Git. It's best to just store it there. You can be able to access it anytime or even send it in case you want to even work on another PC. So I'm just going to create a new project now. So this is the project. So how will you know you have created a new project? So once you, at the top of your R Studio, you are going to see my first project. Once you are able to see this, it means you are on an existing project. So if you see only R Studio, you are not on a project. So you need to create a project. But once you see the name of your project here, that means you have already opened your project. So now you now have your R opened. We have 4 windows in R. I think I might have restructured mine because it seems by default this should be in this place. But it's still the 4 windows we have. If I can still recall, I think, or maybe, okay, yeah, this is the default. This particular console and here are on this particular part. So we have 4. This is the first window. This is the second window. This is the third window. This is the fourth window. This is the third window. This first window you're looking at is called your editor. You can write your R script there. You can write any programming language in this place. It just depends on the file type. Once you go to File and New File, you can see the different kind of files that R supports. R scripts, Quarto. Quarto is a kind of document rendering system. We have Markdown, we have Web App, we have Plumber API. We have different kinds. We even have Python scripts if you want to write Python in R. So this is where your new file, this is your editor, is where you actually write your scripts for your code. And you can use the new file to create any kind of file you want to create. Then the second one is called your environment. Generally, it's called the environment, but it also has other things like history, connections, and also a tutorial. I want to learn a tutorial from this place, but mostly use it for environment. So environments are variables that you have already created inside your system. So for example, I can create a variable called so you can see it in this place. I just created a variable called X. And you can see it's already in my environment. So this is how the environment works with. So it has other tasks, but mostly the environment is what it's mostly used for. The third one is your console. So the console and the editor almost works in the same place. The only thing is that you can save the editor, but you cannot save any information on the console. Like now, I can't save this. I can't save this because I've not write it on my editor. But if I write it in this place now, I can save it. If I write it here, I can save it as a file. I can just say Control S, just like you are saying in Microsoft Word, give it a name, my first scripts. And you see it's already in my project, and I save it. So I can access it, I can even give it to someone. But what is in this place? So this place, just take this place like your rough. Maybe on an exam, you have where you're writing your answers, you have your rough sheet. You know your rough sheet is not going to be submitted. So this is like a rough. Maybe you are trying to do some commands or trying to test some code. You can write them in this place before now writing it in this place. So this is your console. And on the console tab, you have your terminal. So you can use this to access your directory. This is where you interact with your directory. Maybe you want to save a file, you want to access another terminal, maybe Git, or maybe you want to access Cloud Code or any AI terminal, or any terminal that you're using. You can actually access them through this particular place. Like now, I can just, if I have a repository, I can add it to GitHub through this place. So they work differently, this console and terminal. Console is like more or less interacting with R, while terminal is more or less like you're interacting with your PC. Then we also have background jobs. Maybe you have things running, you get the information in this place. But these are the two major things you need in this particular third window. Then we have the fourth window. Fourth window is more comprehensive because we use most of the tabs here. First of all, you have your files. And this file, just by mere looking, you already know what it does. It shows all the files in your project. You can see this particular diamond sign I was telling you earlier on. This is it. And you can see the script I just saved now. This is it. If I have a data set, you're going to see it here. You will see the size and you see the last time the data was modified. You're going to see a lot of information in this place. You can even rename. You can rename on any of your projects. I can decide to rename it here. You can do anything. You can even delete it from this place. So instead of going to your file manager or your system files, you can just do anything you want with the data set inside your project. So these files tabs make that easy. Then we have plots. Plots, anytime you build a visualization, you are going to see it in this place. These plots, you are going to see it here. Anytime you build a visualization, you are going to see it in plots. Or you create a visualization, you see it in plots. Then we have packages. So I already explained packages earlier on. These are the defaults. Some of these are default packages in R. Why some I installed them from the R repository, which is CRAN, where you install, where R packages are usually pushed to. So you can either use code or you can just click on this button, install. You type the package name. I can see tidyverse. You can see tidyverse. So any package that does not come up here is not on CRAN. Maybe you need to install it from the GitHub repository directly. So I can just see ggplot2. These are all packages that you are seeing. So you can just type the name. Or there's a faster way, which I'll also show you, where you can just use the code to install that. If you also want to update a package, you can click on updates. So, and there's also a faster way, which I also show you in code, but all of these are just the buttons you can click on to do that. Then we have help. So one thing that makes R to shine compared to other tools is this help or documentation you have. You can look at a function inside R. So you can just see this is a particular function I've already looked at. You can also look at other functions. You get the help in this place. So this is more or less like a helper that you are having when you are stuck, when you are trying to write some code or perform an analysis, you want help about a particular function or how to do a particular kind of task. You can just come to this place or even search in this place to what? To look for help. And this works offline. You don't need to even be connected to the internet to use this. Then we have viewer. So this one is for building web applications where you're able to see this. So viewer and presentation, two of them are for viewing or maybe rendering. You are rendering a particular file, a document. So we are going to be using this viewer or presentation. So this is it for the 4 windows that we have in R. If anyone have a question before proceeding, can please let me know. Maybe there's a particular concept that you find cloudy. Can let me know before I proceed. Okay, so I think I take that.
Hello.
So I think okay, yes.
Yeah, sorry, just a quick question. Thank you for what you have said so far. It's just
Yes.
concerning the repository online,
Yes.
creating the JIT repository online.
Yes.
Is there like a specific website where you do that?
Yes, there's a specific site that's you do that. We have different sites. So it's actually beyond the scope of the class. That's how I've already demonstrated that, but it's also another distance. So we have GitHub. GitHub is the most popular. It's the most popular. GitHub is the most popular, but also have other sites. I think the one I can remember is Gitpod or something like that. But also have GitHub. We have GitHub. So GitHub is actually the most popular. You create the repository there, then you'll be pushing your code there. So it's like a Google Drive in layman terms, like a Google Drive for code. So instead of storing your files inside your drives, you can just be pushing your code to that place and you can pull it from any system. Just log in to the site and can pull it on any system locally inside where you are trying to work on.
All right, thank you so much.
You're welcome. Okay,
Hello,
so
sir.
I think
Yeah, I have a question too. Thank you for
okay.
the presentation. My name is Selma. Please,
Okay.
I didn't follow when you were. I was following while you were sharing how to save, creating a new project. But then,
Okay.
what the difference you said between the new and the existing directory, I couldn't follow. And then you said something about saving it online, the GitHub directory. I also didn't follow that part. So please, maybe if you could just briefly just go over it.
Okay.
Thank you.
Okay. So okay, I'll go over it now. Yes. Okay. So when you create a project, I told that you have okay. I think because I've already let me just
Okay. Please, can I add? There are some
okay.
questions in the chat here as well.
Okay,
So,
okay.
yeah, I think you can answer all these questions together. Please, how did you connect it to GitHub? Then,
Okay.
okay, I think this is a suggestion. It will, okay, it's like an answer to what the question here is saying. But I think you
Okay.
can go through how we can connect our studio to GitHub as well. Thank you.
Okay. Okay. So okay. So okay, this is the new project, just as I said earlier on. And so I told that these are the three options you have. You use this when you're creating a new folder. This new directory. You use this when you're creating a new folder. You go to new projects. So this new directory, you are creating a fresh, brand new folder that you want to work on. Use existing directory. Maybe you already have a folder, you have been doing something in Excel. Maybe you have already organized your work. You have been doing some things in Excel, maybe in also maybe you have also been typing some things in Word document, and you already have the folder, but you don't go and create another folder. It's, for example, your thesis now, maybe your master's thesis or PhD thesis. You are already working on a folder already. You don't want to create another folder. So you just pick that folder and create an R project inside it. Because I told you an R project is a folder. So what just makes it different is just that R gives a tag that, okay, this particular folder is a special type of folder that only me can read it. So that is where you now go to existing directory. So existing directory, you just pick that folder. You don't need to create a fresh folder again. You pick that folder. So that is where you use existing directory. Then for version control, you already have the folder, but this folder is not on your system because the folder is on your version control system, GitHub, for example. That is where the folder is. So you want to bring that folder back to your system so that you work on it. Maybe you have been working on it on another system. Then you're not close to that system. You want to work on your file or on your project on another PC, or someone wants to work on it, or you want to help someone on their project. So this is where you use version control. So in version control, you have two options, Subversion or Git, but this is the most common or most popular, this particular Git. So Git is a system that actually I think what's the best PR? Okay, let me put it like this. So Git is a system that actually tracks your project, your changes in your project. A situation can happen whereby you have been working on the project, large project, you have been working on a project for 3 years, and there was a particular change that you once made. You know you are going to be cleaning code, you are going to be shifting code, be adding things. How can you track that change that you made? So this is what Git does. It tracks it. So you can go back to 5 years ago. As far as you have already been storing, you have been using Git, you can go back to 5 years ago. That change that you made, that particular code that you made that you have forgotten, you can bring that particular code back. So that is what Git does. Then we have what we call a repository, a Git repository like GitHub. So what they do is that they use that technology, Git, to now what? Store that code online. So which means without GitHub, your Git is going to be on your system. If you lose the system, that's it. You have to start afresh. But with GitHub, if you change your PC or anybody all over the globe, if they are using another PC or want to collaborate with you, they can still use that particular Git file that you have that has been tracking your project. So this GitHub, you can be able to pull your project from GitHub. So you just use Git, and that's what's called a repository URL. So repository URL is a URL you get from GitHub that you just put in this place. Once you put it, automatically the name you used on GitHub will appear in this place. And once it appears, you're able to create that project on your PC. So because GitHub is beyond the scope, I don't want us to go there. It's also another topic on its own. Learn is because most of us are familiar with it, but maybe in the future we'll try to also or even our paid course are going to treat it. So I'm going to how you can store your code in GitHub, how you can pull it, how you can create repositories and various things. So I don't know if it's clear. Those that were asking questions regarding the projects, if what I've explained is clear.
Yes, sir. So much clear. Thank you so much.
You're welcome. Okay, so I think that is for the R projects. Then, okay, so let me just explain some of the core building blocks in R. So in R, we have what we call variables. We have what we call vector. We have what we call function. We have what we call data frame. There are more than this, but for the basics, I think this should be sufficient for you to understand what's going on. So a variable is a container for storing values. I created one earlier on. You can see it's still around. This is it. And it's also consuming memory. If you create 1 million variables, they are all consuming memory inside. So you are creating something. So it's like you are storing something and you want to access it. That's when you create a variable. You want to store a number. It's like you're putting something inside a container. So you want to keep it for later on. You want to use it later on. So that is where you create variables. So the variables are created using the assignment operator. So funny enough, you can also create it using this equals to sign. But it's encouraged to use the assignment operator. So the assignment operator. So the assignment operator is alt key with minus. Alt key with minus. That's the shortcut for it. Alt key minus. It's always good to use the assignment operator instead of the equals to sign. So the equals to sign can use it maybe when you're doing some filtering, but best practice, use the assignment operator. So use it to create a variables. So you can see an example in this place. I created a variable n cases, and The value is 353. So if I want to run this line, I'm going to say Control Enter. Control Enter. Control Enter is going to run it. So you can see it has already appeared in this place. If I want to run everything here, I have various options. Either I can highlight it. I'll highlight all of them. And I'll now say Control Enter. I can run all the codes here. Or you can just decide to click on this source. This source will run all your words. This is also another option. This source button. So any of them that is comfortable with you, you can use that. So this is it for a variable. Then we also have what we call a vector. So when you are creating a variable, you can only put one value to one variable. But when you have, what if you have multiple values? How do you assign them to a single variable? Because you cannot be, if you have 10 values, you cannot be assigning them to 10 variables. You create a variable, one variable, two. You want to assign 10 values to just a single variable. So how do you do that? So this is where vector comes into place. So vector allows you to be able to what? Store values into a single variable. You can see we have 5 values here. You can even store 30. You can store up to number of times. So as far as you have put it inside this particular C, they call this the concatenate function. C with brackets. C with brackets. This is it. They call it concatenate. So this particular function is what you use to create a vector. You can't create a vector like this. It's not going to work like this. So it doesn't work like this. Or you just say you want to put brackets. If you put brackets, it becomes another thing else. So it doesn't work like that. So you just have to use the concatenate function. And it only takes the same kind of values. You cannot have something like this. I can't put something like John. So if I run this now, so it's going to work. But why it worked is that these ones are no more numbers now. It has forced it. It has forced, because I already have a single, it's a rule. A vector must be of the same data type. If you're having numbers, it must be numbers all through. If you're having strings, it must be strings all through. So, but the fact that I've already put a string here called John is going to make all these, there are no more numbers again. You can see they're already having quotation marks, because that is sign of a string or character in R. A sign of a character in R is when you see this quotation mark. So this John has already affected all of them. There are no more numbers, because it's already a rule. A vector have to have the same data types. So if I'm to remove this now, I'm just put 7 and I run this. So you can see now it's now a number. Then we have, so that's it for the vector. Then we have function. So function is like a procedure, a process you apply on variables. Like a process you apply on variables. So you already have your variables. Then what do you want to do with them? You want to work with them. That is where you use functions. So functions are things that use variable to, it's just like tasks or processes that you use with variables. So a function must carry a variable inside it. So a minimum of 1 variable, depending on the kind of function it has. Some can have, they can use more than 5 variables. So a function allows you to be able to perform tasks with variables. So this is an example of a simple function in R. This is the mean. So the mean calculates, just like your mean, it calculates the average of variables or a particular vector. So I already created this vector now that you see here, ages, which contains 5 values, was a single variable. This is it here. You can see. Then this is the mean ages, which is my function. So I'm going to be putting this particular variable now inside this function to get the what average. So when I say Control Enter, you can see that I'm having 12.4. 12.4 is my mean. So this is just the simplest function that you can have in R. You have other complex functions. Some have what we call arguments, the things you put inside. That's why I said a function can carry more than 1 variable. So this one is just carrying only a single variable. Some can carry more than 1. Then we have a data frame. So a data frame is like a spreadsheet. What you see in Excel is a data frame. So, but it's just what is called in R. We call it a data frame. So Excel can call it a sheet. So, but in here, we call it a data frame. It's just your simple data that you have. So it's also a function. If you want to create a data frame, you use the data.frame function. Then you can now see this particular function is now using more than 2 variables. We have variable 1 here, which is ID. And we have variable 2 here, which is age. So ID that you're looking at in this place is a column. Age is also another column. And they must be of the same length. This column that you are seeing is a shortcut of just writing this 1, 2, 3. So it's just a shortcut. They're the same thing. Just like saying 1 to 3. So that's what that particular column means. So it must be of the same length. So if I can have something like this now, I say score, or let me just say name. Then this goes to John. Then we have Mary. Then we have Adam. So this is okay. So I think I need, let me off this AI, sorry. Okay. So I think, yeah, we have another bracket here. So I just added another variable here, which is name. This is name. So it's also three. This is also three columns, 3 rows. I mean. So if you want to also create it, you just say Control Enter also, and you can see it has already been created. If you want to view your data frame, you just click on this button here. You can see it is already showing here. So you can even see details about it in this place. So your data, you can just see some summary or descriptive information about your data in this particular place. So this is how you can work with data frames. So these are some basic things that will help you throughout the course before complete the course on understanding function, variables, vector, and also data frames. Is there a question before I proceed? Okay, I think I just take that as a sign to proceed. So we have what to call a pipe operator. So a pipe operator. So I think Control-Shift-M should be the sign. So the pipe operator, okay, let me just write it. They are the same thing. These two that you're looking at, this is actually comes with the default R. Then why this was the original one that comes from the package, the initial one before it was now implemented into R natively. So this is the native pipe operator. This one is the package pipe operator. I think it comes from the Magitra package. That's the name of the package. Once you install tidyverse, you should be having this. So once you have already installed R, the current version, there is a settings here that allows you to use the native pipe operator. So you just go to your tools, you go to tools, you go to global options, I think console or code. Yes, you go to code. Under code, you see it here, use native pipe operator. So this is the R versions that it means. You can check on this. If you want to be using this particular one, you can just uncheck this. But if you prefer this one, you can just check it. So anytime you want to use it, you just say Control-Shift-M. Control-Shift-M. So that's the shortcut for it. So what this does is that it's a way of chaining functions. These are 2 functions that we have. One with the pipe operator, the other one without the pipe operator. So this one has the pipe operator, while this one doesn't have the pipe operator. So if you look at it now here, the first thing that we're doing here, the way function works, it executes the one that is internal first before it goes to the external one. So first of all, we need to get the mean of the ages. After getting the mean of the ages, then we now round it up. Because the mean of the ages, as you saw earlier on, was 12.4. We now round it off. So once we round it up, we're going to see that we're going to be having what? So I think, let me just use, let me see 0. So let me use 0. So we'll round it up to the nearest whole number. Now, we're using the round function. This is what the round function does. It rounds to the nearest whole number. So once we do that, we are able to get. So sometimes it can get complex. You can have 5 functions being a function inside a function, inside a function, inside a function. It gets messy. So that is where the pipe operator actually comes. So it allows you to be able to chain functions. So first of all, you have your ages. Then you now say, this is my ages. I want you to get me the mean. You chain it to your mean. So you don't need to put anything in this place again, because I already using pipe operator. This pipe operator will put this inside here for you, because you're already using the pipe operator. So you don't need to be able to put anything inside here. Now, the next thing that you now do, you don't need to now put all of this again to inside here. This pipe operator will put all of this inside this round function for you. So this is where the pipe operator gets interesting. So if you have 20 functions that you are using, which you are going to be seeing, I'm going to be doing some steps which might need 5 functions, 4 functions. The pipe operator is what helps you to be able to chain those functions together. So once you chain them together, you're able to execute your tasks effectively. But once you have them, a function inside a function, it gets confusing. And you can see this is a step-by-step approach. So this is the advantages of the pipe operator. So now back to our course, some of the key packages that we're going to be using. We're going to be using the tidyverse, the janitor, and lubricate. So let me just go to so this is the one file that we have in this place. These are what we're going to be using, the packages are going to be using. So I already have them installed on mine, so which means I can call them like this. But if you don't have it installed, you need to call this. This is a comment, by the way. This is what we call comments. If you want to create a comment, like you are creating an explanation for your code. So you need to start with an hash. Once you start with an hash, then you can comment it. So if you want to highlight, if you have a text you want to comment, a group of text you want to comment or code, you just highlight it and you say Ctrl-Shift-C. Ctrl-Shift-C is going to apply comment on it automatically. So this is a comment. So these are our packages that are going to be needing. We're going to be needing tidyverse. So the reason why I'm just installing tidyverse generally is that we actually have some package you might need, but tidyverse just install all of them for us. So we don't need to be installing some of them individually. You can see with tidyverse, we get these particular packages installed immediately. We have dplyr. Dplyr is used for data manipulation. I want to filter, I want to select, I want to create a new variable. So anything regarding data manipulation, you use dplyr. Anything regarding data visualization, you use ggplot2. Anything regarding string manipulation, use string R. Anything involving data cleaning, I want to change this text from lowercase to uppercase. I want to fix all of these characters. I want to arrange some of this. So anything that involves data cleaning, you use tidyr. Anything that involves importing data, you use readr. Anything that involves importing data, you use readr. Then we have janitor. Janitor from the names is also used for data cleaning, but it has some special functions that it makes data cleaning very easy. Then we have lubricate. Lubricate is used for manipulating dates. You want to work with dates types. So date types are columns on your data frame that are in dates, maybe date of reported case, date of birth, anything involving dates. If you want to work with it, use lubricate, or even time, use lubricate. If you want to now have an overview of your data, use what? Scheme R. Scheme R. Now, how do you now install this package? I already showed you one approach earlier on, but this is the fastest way. You just use your install packages, and you can see what we are doing now. We are putting them inside this C. You can't run it like this. If I remove this C now, this function will return an error. Anytime you are combining a group of values, always use the combine or the concatenate function. That is just C. As small as it is a very powerful function that I'm going to be using a lot. So you put all of these values inside C. Once you put them inside that, you now put them inside the install.packages function. So when you put them inside the install.packages function, you're going to be able to install all of them all together. So these are the 4 packages we are working with. We have tidyverse, we have janitor, we have lubricate, we have here, we have this one's tomorrow. I think we'll be using them. We're going to be using this tomorrow. Then we have scheme R. So EpiKit is more or less like tools for epidemiology you have here. So we also have the here too. It's also part for some of the tools for epidemiology. You also have scheme R. Now, after installing your package, you now use the function library. So this library function is just like more or less like you already installed them. Installing is different from using it on your work. Installing means that it's on your PC, but it's not available for usage. So for you to use them, you need to call using the library function. When I say library tidyverse, it means make tidyverse ready for me. That means make the functions of tidyverse accessible to me. If I call a function of tidyverse, like mutate, if I should call this function without loading tidyverse, it's going to bring an error. It's going to bring an error for me. So I need to load this package for me to be able to use it. So first step, you have to check if you have a package using install those packages. If you don't have it, then you load it using what? Library. So library, you are now able to put that particular package name inside. Then you can now what? You can now load that particular data and that particular package. So I'm going to just highlight this and load. Control Enter. So I already have them. Let me just stop this. I already have some of this, so let me just comment on this. So you can see I've already. So anything you run here, you always get it on your console. Anything you run in this place, and your errors can also show in this place. So you also want to stop a code from running. You can see I pressed a particular red button there. You can just press that to terminate any code that is running actively. So that's it for the key packages that we are using. Okay, so before I go to part 2 now, are we clear with this part before I proceed? Okay. So I guess all of us is.
Sorry, will we be installing these packages today?
Good morning.
You said?
Yeah, good morning. Please, I have a comment.
Okay, yes.
Okay, so I'm just curious, on the install, like you can call the function install the package and then
Yes.
put multiple functions inside or packages inside, right? Multiple packages inside and then run them at the same time, right?
Yes.
I'm just curious, can I call the library function and then put all these packages also together and then call them together? Is it
No,
possible?
library have to run individually.
Okay.
Yes.
But is there any way that I can?
Yes, there's a way. There's a particular package that loads all of them together for you. In fact, there's a particular package that installs and loads it for you together at the same time.
Okay.
Yes.
Well, maybe we'll
I
get
think if
there.
I can
Thank you.
remember, the function is required. I've forgotten the package it belongs to, but I think
No
that
problem,
function
sir.
is required.
I
Yes.
think when we keep learning, we get there. Thank you.
Yes.
Yes,
Okay.
thank you.
So, any more? Okay. So, I think you can proceed, right?
I have a question.
Okay.
In my packages, I am not able to see schema. Is there an issue with is it updated or?
Have you called the install the packages scheme R? Have you called it?
Yes, I have called it. But when I'm installing, it says there is no package called scheme R.
Wow, I'm coming. I think there should be. Let me see something.
I think maybe it's the version of arrow that.
You know what? Use this option. Maybe you should go. Just click on install. Use this place to install it. This is it here. So it's available. Use this option. Maybe you get it through here. Yes.
Yes, there it's available there. Okay.
Is there?
Okay.
Thank you.
Okay,
Yeah.
before you go ahead, okay, I heard you mention that there's a package that installs and loads at the same time. Hello?
Yes.
Okay, it's Pacman. Maybe you can try showing them.
You said?
Pacman package. Pacman.
Okay, yeah. Pacman, yeah, I was trying to remember. I know it's Pacman. Require function,
Yes.
right?
The package.
So
That's the package. It will install and load the package. And if it's
So
not
this is it.
installed, it will install it
Pacman.
automatically. Pacman.
Yes. Maybe I might even have it. I don't know. But let me just see. Store the package is Pacman.
Okay.
So this is it. Think function is require. So yes, this is the function. Okay. So require. This is the function. Trying to think of a package I don't have so that I can test with it. Require, let me see. Schema. So I'm trying to think of a package I don't have to use with it. So don't know. Let me see. Tidy text. No, tidy, I think it's tidy text. Yes. I don't know. Let's see. What is it now? Tidy text. Maybe let me just pick an example from here. Okay, it's actually the library package. So it has a library function, as you can see here, but its own is different. It works in the sense that once you don't have it, it's going to install it for you. So once you just call library, let's say you put it, I already have it on my system, for example, tidyverse. So once this library now, once you install the Pacman, is going to overwrite this, or better way said, you can even use it like this Pacman library. This is a way of explicitly stating a particular, some functions conflict with R functions. So you have some packages that use functions that are also in R, in the sense that once you load those packages, they're going to overwrite the functions that was inside base R functions. Let's say you have min. There's the one that comes with the default R, which is base R, and there's one that is in another package. So once you load that package, it's going to overwrite it. So Pacman also has library, as you can see. So this library uses it to load a package. But what makes it different is that this one, instead of loading it, is going to install it for you if you don't have it. So once you just load it, I think it's because, let me see. It's a library Pacman. Pacman. Okay. So I'm trying to see why it's failing. Okay. So this is just an example. This is the sample package that has been given. So I think after loading the library and the Pacman library, you'll be able to use the library function to install it if you don't have this package. So, but I believe you guys can try it on your system. You load the Pacman and use it without installing these packages. So you just load the Pacman and you can now use the library to install these packages without calling this particular install.packages. So I don't know if we can proceed. Okay, I think I'll take that as a sign to proceed. Okay, so we have our part 2 of today's session. We're going to be importing and exploring our data. So if you go to our files, I want us to have a view of our data first. Or okay, let me just do it like this. If you go to the folder, this is the data folder. These are the data that we have. So this is the raw one. This is like the one that is from the surveillance site. This is the raw data. So
sorry, please, we don't have the data. Can it be sent?
Okay, I think she should share it. I think maybe she shared the repository. So Ma, please, can you share the repository for them so that they can be able to view the data?
Sorry, excuse me. Okay.
Yes.
You said?
Someone is asking of the data, please.
Okay, I should share the repo now.
Yes, maybe you should share the repo now.
Okay then.
Another thing is that I don't know, some of them I think some are not familiar with how to load it.
Okay, I'll share the files here on the chat. I'll share the
I think that
data files.
Is there a documentation, like a process in the repo on how to load it on their PC?
Okay, which one would you want me to do? Should I share the repo or you want me to share the files?
I think share the raw data is better. Yes, just to make it easier. Just share the raw data.
Okay.
This
Okay, I'll
particular
share
one,
it now.
especially this one. Or you can just even share all of them. Just share all of them. Just share all of them.
Okay.
Okay, can I proceed? Okay. So this is a function that you use to load your data into our read CSV. Read CSV is what you use to load. So because my read CSV, the way it works, is already on your project. It's looking at your project. So if you have your data inside a particular folder, you now start calling the data name. Like I'm calling it here now, data. You can see I'm calling data now. / then the name of the file, which is this. It's very easy. If you are not using a project, you might now have to now start calling your desktop name, start calling your my documents, all those kind of long procedure. But that's the advantages of using a project when you are creating your when you're trying to perform your analysis in R. So this is how it works. This is my project, disease surveillance course. This is the project. And these are the contents of this project. So this read CSV looks at all these particular files here. So if your data is inside a folder, so you now start calling your data name first. After calling your data name, then you now say / then the name of that particular CSV file. So this is how you can now. So after you now put that in quotation marks inside your read CSV function, then you now say Control Enter, you run it. So you can see what we are having in this place now. So after running it, you're going to get some information. Your rows, 353 columns, 353 rows. Your columns are 11. You even get information about your data. You can see it's telling you that out of all your columns, 10 of them are characters. See them. Case ID, name, sex, word, and so on. And only one of them is what? Double. So double means numeric with what? Decimal points. We have what's called integer, int. Integer means a numeric that doesn't have a decimal point. So when you're talking of double, it means a numeric with decimal points. While integer is a numeric without decimal point. I don't know if it's clear. So then you just have some other information in this place. So I already loaded your data. It's just showing you confirmation that I've loaded it. So how do you now view it? So we call it line list raw. This is the name of the data. So you can just click on this place. If you click on here, this button here, it's going to open. So you can see I have some information I have in this place. This information are just telling me about my data. Case ID, you can see I can just look at more information about this. How many of them are unique? So how many of them, the minimum length? So these are some basic information that you have about your data. It's even giving you the distribution. You can see under sex. It's telling me how many are female. Aha. So this is where our data cleaning will come. So we need to fix some of these because we're supposed to be having only two gender here, but we are now having multiples written in different formats. You can see for that of the age, look at the distribution of the age. So you can see RDT results. So all of these are just informations. If you want to clear it, if you want to bring it back, you click on this summary button. If you want to take it back, you just click on this, or you just click on this, it will go. So these are our data now. So one important thing when you're trying to analyze, you always try to understand your data. You don't just work with it directly. A lot of things are wrong with this data as I'm looking at it now. So let's start with the first column. This is our case ID. But we have a problem in this place. Can you see it? This B is not supposed to be there. Maybe it was typed mistakenly. The person, when typing 3, he typed B. So this B is not supposed to be there. We need to deal with that. We have our name. Look at the name. And the name is supposed to be in center. That means each word should be in the beginning of each word should be in uppercase, which some of them actually comply with, some did not comply with. You can see this Blessing Ogundele. You can see Danladi Nnamdi. You can also see Tunde Bello. So some of these names that are looking at, some of them are having uppercase completely, some are starting with uppercase. So this is also our age. We also have missing values in age. And can somebody age be this, 999? So this is also a problem we need to deal with. So I hope as we are seeing it, we are tracking some of these issues, we are going to be dealing with them. Look at our sex. The person that recorded the data recorded some as just F, some as uppercase F, some as smaller case F. He also recorded female as just starting with uppercase F. Why? And just like this is how we even want it to be. So, but he recorded some like that, some did not record it like that. The same thing also with the male. We also need to deal with that. Then word. So you can see our word here. Sango, Apata, Bodija, Ring Road. So some of this. So this is it. Then we have date of onset. So look at the dates. There are some problems. There are some problems in these dates, as you can see. There are a lot of issues here. Some are having slash, some are having hyphens, some are even starting with year. Look at it. Some are even having the name of the month. We need to treat all of this. Also, the date of report, the same thing. And also, your column names in R are not supposed to be having space. This is also another problem that we're having here. Date of report. Column names in R should not be having, in fact, variables in R should not be having space because a column name is also a variable. It should not be having space. So when you are creating something like this, you use underscore, like underscore off, or you just start your off maybe with even a capital letter. But most of the times you use underscore. So instead of writing date of report with space, I write date of report with underscore. Then hospitalized, yes or no? So in some places they say the one to be what? Hospitalized. And even the hospitalized is having question mark. We need to deal with that. If you also look at these two also, some are having 0. 0 means no. 1 means yes. So it's a mix. We need to make it uniform. Yes, it should be either yes or no. If you also look at the RDT results, you can see some of them are having uppercase, completing, and positive. These are things that will give you problem when you're trying to analyze. Because if you're having positive in uppercase, positive in lowercase, and positive that's starting with only uppercase, these are recognize that as 3 variables. Because there are 3 different things according to R. So you need to make it either completely in lowercase or completely in uppercase or completely positive should start with the word should start with what? P, which is in uppercase. So all of these are what? Giving the impression of multiple variables to R. So this is why you need to deal with this. Even in Excel, at times you use find and replace to handle some of these kind of issues when you're having it being stored like this. Because when you're trying to analyze your data, you need them to be what? To be uniform. Even the outcome will also have the same issue, and also our source of water will also have the same issue. So we're going to be solving all of this now in R. So I think we have already treated importation, and we're also going to look at the line list now. This is also a way of going deep. So we have two functions here. We have dimension. So dimension, when you click Control Enter, is a way of checking your number of rows and columns. We also have glimpse. Glimpse is another function that gives you details about your columns. You can see, you can know which one is character. You can even just look at some of the values there. And we also have the scheme from the scheme R package. So this is a little bit detailed, the scheme. So what the scheme does is that it gives you missing observation details. So you can see the variables here that we have in our data. You can see the number that are missing. So under our variables now, we can see sex, we have 16 missing sex values or records. Under date of report, we have 5 missing. Under date of onset, we have 8. Under hospitalized, we have 14. Under outcome, we have 3. Complete rates. Completion rate means what's the rate of completion? That is, what is the percentage of observations that are actually filled? So you can see here we have 95.5% completion, because that means 95.5% of our observations are filled. So the remaining ones are 16, which is in this place, that are not filled. So these are just some of the details you can get. You have your minimum value, you have your maximum, we have empty, we have number of unique. Number of unique values is just the number of unique values that you have there. Maybe you can see ID is 341 because ID is supposed to be unique. So then we have white space. Then we have so you can see this place that we have is for character variables. Why for that of numeric variables are different. So numeric, you even get a small histogram in this place that shows you the distribution of the data. You have number of the missing here is 19. You have your completion rate too also. Now you have your mean, because you are dealing with numeric data. You also have the standard deviation. You have the lower quartile. This is the first quartile. You have your second quartile, and you also have your this is the first, the second, the 25th percentile. You have the 50th percentile here. You also have the 75th percentile. You have the 100th percentile. So all of these are measures of partition that you can actually just view on your data. So all of these are just basic descriptive statistics that the scheme functions allow you to view. On a normal day, if you want to get all this information, you will have written like maybe 50 lines of code. But you can see that this scheme function makes it easy for you to get all this single information, all this information just in a single go. So that's it for looking at and importing our data sets. Before we go to part 3, is this clear? Can we proceed? Okay. So I think you can just proceed.
Okay. I think we have a question in the chat.
Okay. Okay, what's the question?
Okay.
Okay, so what's the question? Okay, are we there?
Yeah, I think some of us joined later, so we are finding it very difficult to follow. Can you be maybe pasting those commands in the chat too, so that somebody can also keep pace? Thank you.
Okay, which command? Okay, well.
For instance, like this importing now, right from importing, I was able to get the file, but the importation process. So if to say you put it in the chat, I can follow it and then also continue. Thank you.
I think, well, let me
How did you show
Hello, what's the issue?
How did you show the data in a table form? Like the way you showed it.
Okay, you click on this place. Button. This is the button. Can you see it here under your environment tab? You can see this button. You go to your variable, this value that I just stored now. This is it. Line list raw. We just created it here.
Okay. Okay.
Then you just click on this place. Once you click on here, I think this is what you're talking about now.
Yes.
So you can see it opens once you just click on this place.
Okay. Thank you.
Okay. So for those that joined late, sorry about that. So you can, I think we have not gone that much far. We just talked about installing the packages and also loading the data. So I told you that if you want to load the data, you just follow it, your folder name first. The folder, if your data is not in the folder name, you don't even need to put, you just put all your data name. Your data is not even in the folder, just put it like this directly. But if it's in a folder, you need to put the folder name first. Yeah, like it's like you're telling the function read CSV, like go and search for this data under this folder. So go and search for it. So it's now going to go and search for it for you. Then you now get that particular folder. Oh, so
in my case, I copied it to the desktop. So how would I reach that?
Yes, you not create a project and you might have troubles trying to load that data.
Yeah.
So I think we talked about projects, creating projects. So I think the best thing you should just do, just go to your file in your R, create new projects. So you just create new projects. Let me do it here. Just go to your file, new projects. And click new directory, then new project, then just type the name of your project you want to create. You can now save it in this place instead of documents. You can just leave it as desktop. Now, after you now do that, it's going to open a new window for you. So now just go and type those codes inside that particular new window, create a new file and type it there. So that will make it easier for you to be able to load the data. So what you just do after downloading the data, just go and paste it inside that folder inside your file manager. You go to your file manager, you look for this project you created and paste that data inside. So once you open R, you'll be able to see that project in this place. It's much more easier. If you not create the project, you are just loading from your desktop, you might be having problem loading it. So you have to start searching. You start giving it commands to search for your desktop name, search for where it is. So it's a long process. So, but once you have it in a project, you have already enclosed it, you have like caged, you have created a caged environment. It makes it easy to load your data inside a project. So I don't know if that's clear.
Yeah, it's clear. It's clear now.
Okay, so I don't know. Thank you.
Okay, so Ridwan,
There's a question?
I think there's a kind of a question here. Okay, I don't know if it is just a mark issue, but to import the data name needs to be placed in between quotation marks for
Yes,
the read.
data needs to-
Yes, no, it's not a mark issue. I don't think so. So you can answer that question.
Okay, what's the problem? What's he trying to?
I think he is on a mark. I think so. Simon, I hope I pronounced your name well. But I think he's having issues with either putting the file path in double quotation mark or not on a mark. But I think irrespective of which system you're using, if you're using the function read_CSV, your file path has to be in quotes, either a single quote or a double quote. So I hope I answered correctly, Ridwan.
Yes, he has to be in single or double quotes. Yes. And it's very important you guys want to reproduce what you are doing. That's why I started with the project. And I don't know of those that entered late,
Okay,
but it's
thank
very
you.
important to create the project. If you don't create the project, you might face a lot of issues trying to load the data. You face a lot of issues. Yes. So after creating the project, then you make sure that that data is in that project. You just go and copy it from your downloads folder. And just because I told that the R project is actually a folder in your system. So just go and copy that downloads, the data I already downloaded, and just paste it there. So if it's not your project, you face it. You might end up loading the data, but it's going to give you a lot of challenge. Because you have to, ad is going to start looking, because the way it loads data, it doesn't just load the data just by calling the name. It needs to look for which specific folder is it. I know you have your PC, which is your user, then you have your local user, you also have your documents, so all those parts, ad needs to follow those parts to get that particular data. That is why it's very important you create your ad project so that you don't face any complications. Yes. So I think maybe I don't know. I think I have the PDF slide. So I think it will have been best for those that are having issues to just look at how. Okay, maybe I'll just go through it on the slide. So I think this is step here. So this is just the step here. I think you can look at it. Your file, your new project, your new directory, then new projects. Then you just give your name of the file that you want to, the project you want to create. So, okay, can I proceed to part 3?
Go ahead.
Yes, I think
Yes.
there's
Yes.
no more questions here. Okay, let me answer this, please.
Okay.
Could you please put the commands there? No, I think at this point, you have the data file. So if it's not possible for you to follow along, I think understanding what the instructor is teaching you is very, very key, because you wouldn't be able to get to ask him the question again when we share the files. We are going to share the files for all those who attended this session. So we are going to collect your emails again, because a lot of people registered, but most people didn't show up. So, but we would like to commend you for attending the session. Then we'll send the files to you as well as the recordings. So please just kindly bear with us. We want you to focus on understanding what we are teaching, not having the file, because you wouldn't have us to answer your questions again. So I hope Yusuf, you understand this. Okay? Please kindly let us abide with that.
Hello, sir. Please, the packages that we need to install.
Okay. Yes, the packages that we need to install, these are the packages. This is it. Maybe let me go to the chat if possible and just paste this. So this, just run this command as far as your system is connected to the PC. Let me go to the chat. Don't know. Trying to look for the Zoom. Just trying to. Okay, I think I've seen it. Okay. Oh, I copied the wrong text. Let me see. So anybody has having problem with the packages, install this. So it should work. Just run this like this on your code. So you just copy it and just paste it and it should work. So I think that's it for that. So part 3, cleaning the line list. So I'm going to clean the data now, which is, I already told you the problems the data is having. So I'm going to clean it now. So first case, we want to clean the column names. I told you earlier on the columns. These are the columns. I told that we don't want this to be in this format. It's supposed to be having underscore. We don't want it to be in a format that is only having space, it's going to give us problem while analyzing. So we need to do that. We also need to remove this question mark. This one also too is also having space. Then source of water is also having that issue. So these are the two I think that we're having issue. So we need to clean those column names. So I already explained the pipe operator. I told that it's a way to chain functions together. So we already loaded your data, which is this line list raw. So we are now going to clean the names. This function is from janitor. So this function is it's a very powerful function. It saves you a lot of stress. You just call it and it will fix all those column names automatically. Automatically, it's going to fix all those column names. Just call it directly. So this is the line list clean names. So I'm going to run it here so that we see the results. So can you see what has happened in this place? Can see that the names have already been fixed.
We can't see anymore. Someone else is sharing their screen.
My screen is not showing?
We can see it now.
Okay. So let me just run this now. Now I'm using this clean names function to clean those particular column names. So if I just run this, I'm not assigning it to this particular variable, a new one called line list. So I'll just say control what, enter. Now you can see line list has already been created. That is the same data. It's just that in this one is different from this one. This one was the raw one I imported earlier on. Why this one now? It was the one I just cleaned the column names. So I'm just going to click on this to view it. You can see that the column names have changed. It's in the format that we want it to be. You can see it has removed that question mark. You can see that it's already having an underscore, all in lowercase. You can see source of water is so what, having underscore. You can see it was different from what we had earlier on. This was the initial one. So you just need to just what, call clean names. Without these clean names, you'll have done a lot of process to just clean those columns. But with this, you just what, you have already what, cleaned your column names. If you now want to get all the list of your column names, you use this function called names, then line list. So you use this function called names, then line list, so you can get all your column names. So these are the clean column names we have. So this is for the column names. The column names have already been cleaned. I don't know if this part is clear. This is very clear with Oliver.
Sorry, sir. I didn't follow, honestly.
Okay. So I told that our column names are having
names. Does it clean all the values or just the columns? I didn't see what it did, the clean names.
Okay. This is our initial data. Can you see I'm having two data in this place? Look at them here. This was the one we loaded, line list raw. I call this line list raw. This one's the one we just cleaned. This was the one we cleaned the the column names. So the clean names only clean column names, not the values in the columns. You are trying to fix, because I told you that R doesn't want to see space in your what? Column names. It doesn't want to see space in your column names. All your column names should be together. And since your column names are separated, then which option do you have? You have option to use underscore. Normally, if you have to clean it manually, you replace those column names with, for example, now source of water is going to become source underscore of underscore water, because we don't want space to be there. Because if space is there, you'll be having problem when analyzing your data. The problem with R having space in your columns is that anytime you have space in your column names, you now have to go and start using this backtick. You can see this sign, backtick. You have to start putting all your column names inside backtick so that R will recognize them, which is a tedious process. Because even some analysis, the backticks might not even work. It might be returning an error for you. So you need to what? Clean those column names to make sure that what? None of them are having space. So this is the initial one that we imported. You can see source of water is having space. RGT result is having space in this place. Then we have hospitalized is having question mark. Date of report is having space. So then when you now run this particular code, line list raw, then you use your pipe operator.
Use the pipe operator. Okay.
Yes, you use your pipe operator to now chain it to this function. On a normal day, this function can still work like this. Clean names, line lists, raw. It can still work like this. They are both the same thing. These two of them, they are doing the same thing, these two codes. But this problem is that when you now start having multiple, like I can see something like this now. This is a chained operation with almost like 6 functions. You are going to be having a function inside a function. That's why the pipe operator is very important. So that's why we use the pipe operator. So for those that came late, that's why we are using the pipe operator. You can still write it like this. But the pipe operator makes it easy to chain functions to what? Another function. So by calling this now, cleanness is now going to what? Clean your whole data. After cleaning your data, then you now run it. You can now see this is our line list. Now, this is the one we cleaned. Now, look at the difference. Can you see the difference? This source of water. Look at the source of water here. You can see this one is in capital case with space. Look at the new one we just did, just with underscore. RDT result is having underscore. The question mark in hospitalized has already gone. Date of report is also having underscore. So this is the difference between the two. That is what the clean names actually does. I don't know if that's clear.
Yes, sir. Very clear.
Okay. So now we have so we are done with that. We have cleaned the column name. So the next is for us to remove duplicate rows. So there are duplicate rows in this place. How do you check for duplicate rows? Before you even conclude that what there are duplicate rows, we have this function called get dupes. Get dupes is the name of the function. So let me write it here. Get dupes. And you just put your data inside. Now we're not going to be using line list raw. Line list raw was the initial one, but we already created a new one now called line list with what? Cleaned column name. So we'll now be using this name, line lists. I'll now say line lists. And I'll now enter. Now, what get dupes does is that get anywhere you have duplicates, so any rows that is having duplicates, or any rows that is being added is duplicates, get dupes is going to what? Bring it out for you. And get dupes is looking at your ID. The column with the most unique values is what it's going to use. You can see now, these are the case ID. AWD0066. AWD0066. 2 values that we're having in this place. So this is a duplicate value. You can see another one, AWD01115, appearing twice. 0123 is also appearing twice. 130 is also appearing twice. 161. So we also have 14 more rows. That's why I see 14 more rows in this place. It just gave us only 10. So we have 14 more in that place. It gave us just only 10. So these are your duplicate values. So you need to remove these duplicates. So the function get dupes allows you to go to what? Know your duplicate. If there's no duplicates, if you run get dupes and you not see any duplicates, then you have no business removing any duplicate rows. So first of all, you need to run get dupes to check, do I have duplicates inside my data set? So after doing that, then you can now say, okay, if you have, then you can proceed with removing them. If you don't have, then you just go back to the next data cleaning task. So after calling get dupes, then the next thing is now to drop those duplicates. So if you want to drop duplicates, use the distinct function. This is it. Distinct function. So you can either call it with the pipe operator, or you can just even call it like distinct. Distinct. Then you now say what? Line list. You can call it like this. So I'm going to be running this function now, and we will run get dupes on it to see if the duplicates are still there. So I'm going to say Control Enter. You can see that our line list has reduced to 341. Can you notice it? Line list is no more 353 because we have removed duplicates now. It's now what? 341 observations. We have already replaced the other one that we had earlier on. So now if I call get dupes now on line list, can you see what it's telling me? No variable, no duplicate combinations found of all these variables. So we don't have any duplicates. We have already what? Removed the duplicates. So it's as easy as that. So once you want to, first of all, you need to call get dupes to check if I have duplicates. If you don't have duplicates, then you now what? Call you now call, if you have duplicates, then you now use the distinct function to now remove those particular duplicates. So distinct automatically removes what? Duplicates from your data. Is it clear?
Yes.
Okay.
Yes. So hello, apologies. I
Yes.
just want to say something. When I try to run get books from my end, it's returning as error. I hope I did not mix up something.
What error were you having?
Get books could not find function.
You have not loaded the package. You have not loaded it. That's why. Get Deuce belongs to janitor. You need to load this. If you don't have, in fact, if you don't have it installed, you need to install it. If you don't have it installed, then maybe you have. Did you install? Have you installed that code I sent earlier on?
Yes.
Then you need to. Let me just paste this for those for the benefit of those that.
All right. Thank you.
Okay. So just load this, then that get dupes will work.
Thanks.
Okay. So next we now have we have near duplicate case IDs. Okay, yeah. So we have two types of duplicates. We have exact duplicate rows, whereby the case ID are the same all through. Then we have another case whereby I showed you this earlier on the line list row. This. This is it. Can you see it's 258B? There's another 258 here. Can you see they're the same individual? Femi Fashola, also have Femi Fashola. Here was a mistake. They're both the same. Assuming there was no B here, get dupes will have dropped it. But there is a B there. So there's also another way we can take care of this. So back to this. So these are called near duplicate records, whereby they are almost what? Duplicates. But it's just that the idea, because their dupes use the most unique column to drop what? Duplicates in a data set. So in this place, what you do now, you say line lists, then you count your case ID. Then you now filter where your n is greater than 1. So let's follow it in an approach. Say line lists. Then you now say count case ID. So let's run this first. Can you see this? We're counting the case ID. We're counting the case ID. So we can just run it like this. Coming just to view all of them. So you can see everyone is having what? 1, 1. So which means what? Everything is already what? Complete. So I've already confirmed that what? Everything is complete. So if you find out that what? There are cases where so what we just did in this place is to check if we still have duplicates. This is another way of checking if we still have duplicates inside the data. Because if we have duplicates, you are going to see, because ID is supposed to be unique. It's supposed to appear only once. So if one of them is more than 1, it means there's a duplicate. So you can now check. It's also another, like a way of running get dupes. But this time around, by checking what number of times a particular ID shows. Now, to now remove this kind of scenario where I just talked about now, this particular kind of scenario. So you need to use, so in this place, first of all, the first thing you do, you call your line lists, then you chain it to what? A function called mutate. So mutate, just from the word, it means to create a new variable. Mutate means to create a new variable. That's what mutate means. You are creating a new variable called case. So that mutate is now going to contain what you use to create a new variable. So my new variable is case ID clean equals to what? Then we now have this string remove. This string remove is from the string R package. String remove. So string remove, I'm going to say string remove. And mind you, please, if you don't know a function, you can always run question mark and the function name to get to know more about it. Question mark, the function name. Once you run it, you'll see information about that particular function here. So it removes matches. So you can see what this. I'm going to remove anything that matches a particular value. So case ID. So you use the question mark to check for a function if you don't know. So string remove case ID. Then we have A to Z. Then we have $sign. So this is what we call a regex expression. So regex expression is used to search. Sometimes your regular find and replace might not work. You need to use regex. When you look at your data now, we already looked at our data. You found out that there was an issue. You already found out that there was this issue now after looking at your data. That one of the value are duplicates and one of them is having B at the end. So, and you need to remove that one that is having B. So you use regex to look for what this just means is that any ID that ends with a letter, because all IDs also end with numbers. All ID are expected to end with numbers. Any ID that ends with a letter from A to Z, you should remove that particular number. Any ID that ends with a letter, any ID that starts with a that ends with a letter from A to Z, remove that number. You should just, now we're not even removing the record. We are still keeping it, but just remove that particular number. So this is what they are trying to do here. So if I run this now, so let me run it with the view so that we see that particular value.
Okay. Sorry, while
Yes.
you're running the code,
Yes.
sorry, Ridwan?
Yes.
Okay, I think Shuaibu is raising his hand. It's been a while
Okay.
since he should.
Okay. What's the challenge?
Okay, so thank you, Ridwan. I just
Yes.
want to know something. I just want to
Okay.
raise concern about something which look you know, people may get confused because we are using the different piping operator. I think we should stick to one because some people are
Okay.
like, because I see that you for the past minutes you have been using this particular pipe operator instead of the other one. So let's stick to one so that people will follow up because most of us are still learning.
Yes.
We get confused on what is Ogari the one doing now? Which one is this one again? Which one is this one again? So I think yes, because I just
Yes.
learned about the base one today. I
I
thought
not even take
this
note of that. Thank you very much. I not take
is the
note
base
of
one
that.
that is the
Yes.
Margarita one that I know.
Yes.
So
Yes.
this one I
Yes.
just learned it today, and then
True.
you are so some people they follow. I think will just be so. Let's stick to one. If it's the Margarita one we're going to use, let's use it. If it's this one I'm going to use, let's use it. So
Yes.
that this thing will just go. Thank you very much.
Welcome. The problem was from my settings, so I not even take note of that. So let me just off it here. That's why. Yes. I think. So I think now if I should just. So I think the normal one is coming up now. So thank you very much.
There's
Okay.
one,
And
there's
there's
still
one
one,
there.
the
There's
first
one there.
one.
The line
Yes,
is
Okay.
sorry.
yes.
Yes. Sorry. Okay. I think. Yes. Okay. Thank you very much for that, please. Okay. So now, okay, I'll be running this. This is another way of, instead of clicking here, you can also view from just, if you pipe it to the view function, you can view your data from this place. Just put the view and you'll be able to view your data here. So it's just like a shortcut. I don't want to create a variable. So I want us to just follow it step by step to see what is happening in each line. So let's see what's happening in each line. So we have removed the trailing letters on each ending, on the ending of each ID, if there is any ID that have that. So we created a new column called case ID clean. So this is our data. This is our case ID. So at the end, the new column is to appear at the end. Case ID clean. This is it. You can see we're no more seeing that value that has B again. Let me even look for it from this place. It should be number what? Number 335. So you can see the B is gone. This is number 335. You can see it. The B is gone. So that B has gone. We have treated it. The B has disappeared. So this is what this particular line is trying to achieve. We created a new column and we now say use the string remove to remove any ID that is having a letter at the end, since every ID is supposed to end with a number. So sometimes some of this kind of data cleaning involves, you need to look at your data critically to be able to know what and which approach you should use to handle it. Then we have distinct. We are now passing it into our distinct. You remember we use distinct to drop what? Duplicate rows. Remember, we used it to drop duplicate rows. So you now say case ID clean. In distinct, you can specify which row should a particular duplicate be dropped by. By default, it's going to look at the most unique row, column inside your data. But you can also specify which column you should use. So maybe you have two IDs inside your data set. And both of the IDs are unique, but you have a particular ID you want it to follow. So that ID is what is good. You can specify the ID that you use. So we're saying use case ID clean. That's what we're trying to say inside this distinct function. That you use case ID clean. You have dot keep all is equals to what? True. So if you go to the distinct function now, so you can see what the dot keep all does. So if true, it keeps all variables in the data. If a combination of this particular is not distinct, this keeps the first row of values. So it's more or less like we're trying to say by keeping our variable. So let's run it and see. Okay, let me put the view. Okay. So by default, it's false. Then we have it here. So this is the case ID clean. So let's look for that 115. There are actually two. Let's see. So you can see it's no more there. It was actually in 335 before. You can see it's no more there. So it's no more there. So this was the initial one. Let's look for the initial one, 115. I think it was 115 or 151. I'm thinking, let me see. 43 p.m. So 258B. Okay, there are actually even two. We have 0015B, we have 258B, and I think those are the two. 258B and 0015B. So we had how many? We have 341. Currently now we're having how many? Let's see. 300 and what? 40? 337. We're having 337 now. So you can see this one was 344. Why we're having what? 337. So which means that what we have ended up deleting those particular values that we're having what? Ending with letters, those particular IDs that were ending with letters. We'll end up removing them and also dropping them. So now we're not going to remove that our case ID. So we have a function called select. So what the select function actually does is that it picks, you use it in selecting a column. I can say select case ID. And if I run this now, so you can see only case ID is appearing. Only case ID is appearing. It also works in the opposite way. If I want to remove a column, instead of now writing case ID, I'll now say minus case ID. That minus means delete or remove that particular column. If I should run this now, you can see case ID is no more there. So this one that we created, case ID clean, becomes our new case ID. Then the next, we now rename it. Rename case ID. That is case ID clean now. We are going to give it that initial name. Because we cannot have columns with the same name in the data. That's why we need to remove that other one and now rename that case ID clean into case ID. So we're now saying case ID clean, which is this. We're now going to give it a new name, case ID. When you now run this, and you can see it has what? It has been renamed. Now, one more last thing. One more thing again that we're going to do. I'm not going to relocate it. Relocate means we should what? Bring it back to the front because it's an ID, so it's actually supposed to be in the front. The ID, then the name. So I'm now going to say relocate case ID. We run this. Okay, what's happening? Okay, I not put the pipe operator in. So you can see case ID is now in the front. So this is how this particular process has worked. So you can see how smooth it looks. You are chaining. This is why the pipe operator is very important. You are ready. It's a step-by-step process. First of all, I need to do this. And after this, I need to do this. And after this, I need to do this. So it's like the way you actually think of handling your data, you can actually lay it out in code. Yes, please.
For every line of code we write, we need to include the pipe operator. Is that what
Yes,
you're
for
trying
every
to say?
line. Yes, for
For every line of code.
Except the
We need
last
to-
one. Yes.
Except the last one. Okay.
Yes.
Thank you.
Yes.
So,
So I
can,
think
can I
relocate.
can I add? Sorry, can I
Okay.
add to the answer there? Yes, it's true. You have to put the pipe there, but I want to just share an analogy now. Whatever you have on the first line, and you're seeing a pipe, it's more like whatever result of your operations on that line is what is being passed to the next one. That is the essence of the pipe there. So is that clear?
Oh,
So you
okay.
still continue to so you're passing whatever you do on the first line, you pass it to line 2, second line to the line 3, until you get to the last
Three.
line
Okay.
where
Last one.
that's
Okay.
the end.
Okay. Thank
Let me
you.
just
Thank
give you
you.
a simple, let me do a simple this thing to show you why it's very important, the pipe operator. This is the
Okay,
view.
good.
This is the last function, right? This is our last function that we used to view it. Now I'm going to do this. I'll now say relocate. Relocate. Then I'll now say rename. You can see how it's getting more messy. Then I'll now say select.
Okay, I understand. I understand.
So you can see what's
So
happening.
the pipe operator, yeah, the pipe operator already captured everything into one.
So this is what it's trying to
Okay,
do.
yes.
So this is what it's
Yes,
trying to
yes.
do.
Okay, thank you. Thank you.
So that's it
So,
for.
sir, please, the relocate. Okay, sorry. There are so many questions there. Let's answer the question. We have Mohammed and Temitope raising their hands there.
Okay. Yeah.
The relocate, please. Does it mean going by bringing the case ID from the last line to the first line, or any line can be chosen?
Let me check it so that you people will be very clear with this. So can you see it here? You use the relocate to change column positions using the same syntax as select. So you are using the relocate to change the column positions. You are changing it from what before to what after that, from the last to what to the first. So by default, it picks from the last to the what to the first. If you already have it at the last end of your data, it's going to bring it back to the front. I don't know if the one asking about relocate is clear about that.
Yes, I'm clear.
Yes. So you can check the documentation for more information on how you can use it more. I saw some examples there. So you can see this is an example here. So this example, this is the data that we have. We have 5 columns here. So if you want to put it after a particular variable, you just use this argument dot after. So I want to put it dot after name. I want to say dot after equals to name. So that relocate to put that particular value after name. You want to say before name, I'll say dot before should be name. So that's how it works. So maybe you want to put it specifically, but by default, it just brings it to the first value, as the first column. So it's clear, right? So let me just remove this. So now enrow, this particular function enrow, use it to know the number of rows you have. Okay, let me just run it for you directly. Our rows have been reducing because we have been cleaning the data. We are having 341 from 353. Okay, I think we have not run. Have I? Okay. Okay, 337 now from 353. This is what we are having now. Because we have already removed some duplicates. We have already removed from some of the duplicate columns that we have. So our data has reduced from 353 to 337. So I already drew that part now. So next, we want to clean text, categorical variables. We want to clean text. Next, we want to clean text. So this is also another operation. If you want to clean your text, we have our line list first. Then we have the mutate function. I told you use mutate when you are creating a new variable. So I'm creating a new sex variable now. I'll now say, now when you use mutate to create a new variable, and the name of the new variable you are creating is the name of a variable you already have in your data, it's going to remove that previous one and keep the new one. If you can see in this place now, I'm saying sex is equals to str trim, then sex. I already had sex earlier on, but this sex that I have now is going to now trim it. It's going to trim my data. So let's run it to see what we have. Oh, come. So what trim means is that in case you're having spaces inside your data, it's actually going to remove those particular spaces. So now they will now have the arguments called inside mutate function. This is the mutate function that you're looking at. This is where we declare the new variable we are creating, and this is where we now declare a condition, because you might apply a condition inside that particular variable. So now I'm going to say, comma, sex is equals to case when. So case when is a type of if condition. Instead of writing many if this, then that, if this, then that, else this, then that. So multiple if else statements. You just use case when. So that case when will now say str to upper. So anywhere it sees a particular value under sex, convert it to uppercase. That is what this particular line is meaning. Anywhere you see a value in that particular sex, convert it to uppercase. Then, if that particular value is among these, so it's like you're going through each row here. Okay, let me check F. F is in uppercase. Then check it if it is what? Male or inside this. If it's any of these two, convert it to this. Okay, then go back to this one. This one is in lowercase, convert it to uppercase. After converting it to uppercase, check if it is inside these two. If it's not in these two, go back to this particular two. If it is in this particular two, then convert it to this particular what value. So this is what is happening in this place. So if it is male, then we have this tilde sign. That means what? This tilde sign is just more or less like saying replace it with what? This particular value. Then you now have your next condition, which is actually this. So just copy this now and paste it here. Now, what this now means is that if among all the values you now saw inside that column, all of them did not even match any of this, then just make it that as what? A missing value. Because you might end up finding a missing value there. So that missing value is not in any of these particular values. So make it a missing value. Now, there are types of missing values in R. We have NA character, we have NA ring. So anytime you're having character values under a column, that is character, then you need to specify the missing value as NA character. So R will know that this is not just a missing value, it is a missing character value. So there's a reason why sometimes we have some of these, because some functions are designed in such a way that it might throw an error if you have a missing numeric instead of a missing character. So that's why I'm using NA character. So this true tilde sign NA character means that any value that is now remaining after checking all these conditions, make it missing. That's what it just means. Just convert it to a missing value. So that's what it means in this place. So we have this now. So when you now run this now, so can you see what's happening? You are no more having those N, F, M again. You can see it's already what? We're already having just two unique values, male and female. Male and female both starting with uppercase. So unlike in here, that we have been having FM. So that is what this particular process does. First of all, you mutate by creating a new value. And we are saying string because some of them have space. That's what this str string does. So it's streaming that particular value under each row. Is going to trim it. Then you apply the case when, such that you are not going to make it uppercase first. And if you make it uppercase, if it is in this, then you make it male. But if it is this, that particular value, if it's among this, then you make it female. Any other value that remains, then you make it as what? NA character. So this is what I'm just trying to achieve. I don't know if this is clear.
Yeah, it's clear. But
okay.
I have a question.
Okay. Please go on. What's the question?
Okay, my question is
I want
can
to
I
know
go
the difference. If you go up, you see the run command button there, then we have source run. What is the difference between the two of them? In case I'm not using.
What?
Let's go to the title bar. You see run, then you see run source, not in the hand.
Okay,
yes.
okay.
And then the other one run source.
You see, this one works step by step. Can you see what is happening? Can you see what is happening when I'm pressing it?
Yes.
It starts from the first place, step by step. Can you see what's happening as I'm pressing it? Why this one runs everything completely? This one runs everything completely. Yes, that's the difference between the two.
Thank you.
So I don't know, is that part clear now? It's clear, right? Let me just move this. Okay, then we now have a function called tabin. So tabin is a way of just summarizing your data based on a variable, like generating a frequency table. This is the function tabin, a frequency table, either one way or two way or three way. So what we are doing now, we are generating a frequency table based on sex now. This is our data, but summarize the whole data based on sex. So if I run this, you can see it has summarized it based on sex. You can see I'll run tabin. Your data is going to be the first thing. Then the value that I want you to summarize it based on. I can decide to say Tabil name. Okay, no, let me say Tabil. I think I should have word. Yes, let me use word. Let me use word. So can you see Tabil word? So I've generated a frequency table now based on word. Can you see it now? So this is how the Tabil function works. It just allows you to see a summary of your data sets based on a particular variable. Then we have word now. Word is also having that same issue. We need to also fix it. If you go.
Can I ask a question before you continue?
Okay. Yes, I'm there.
The sex, there is NA. So those NA, I don't know what are they going to take.
They are missing because they were not even filled initially. That's a different game entirely. So if you want to solve the NA, you need to now start doing missing value imputation. So that's a different goal. So now we are just fixing the data in such a way that we can actually work with it. So the NA was originally not even filled. So that's why you see they're having NA. Yes.
Okay.
So if you want to treat them, you have to start doing missing value imputation, which is also another area on its own, beyond the scope of the course.
So I wanted to ask the question again.
Okay.
Or
Okay.
I didn't get a chance. It's still on that sex, right? So
yeah.
you made a condition that if it's not F or male or F or female and M or male, it should save it as NA character. Yeah. So there are some instances where during collection they may not really say the female as female. It may be spelled as female or like FEMALE. But we know probably that person wanted to spell female. And if it converts it to an NA, maybe automatically it feels like that data that could have been recoded, it has been lost to an NA. So is there a way that we can just check the unique values in that particular column and say, okay, this is how some values were spelled, and then use it to change it to this particular condition you're putting? Is there a way to do that?
Yes. So you can use this function unique. Can you see it? Then line list row. Line list rows are initial data. Then $, your column name, which is sex. Then you run it. Can you see all the unique? Can you see them? These are all the unique values on that sex from the dirty data, from the initial raw data. I think this was what we are trying to point out.
So when doing the case, we should include all these options.
Yeah, so you have to make sure that all your options now is being covered here. So you already know that F stands for female, this one stands for female, this one also stands for female, this one stands for female. So you also know that this, and also all of this already stands for male. Even this one also stands for female. And that was why, if you see earlier on, we started with what? String to upper. Because we want to make sure that we're not even talking about, we want to be talking about case now. So just even make everything upper. They will now start finding which one belongs to which. So no matter what was even written there, first of all, make it uppercase. Whether it was F or small letter F or female all in small caps or female starting with just make it completely uppercase. Once you make it completely uppercase, then check whether it is inside here. So let's say somebody went and started and wrote MLE. MLE will show in this place because this is all the unique values under sex, under the raw data sex. Somebody went and wrote MLE because the person that wrote MLE wanted to write male, for example. So once you see MLE in this place, then you now include MLE here. So you now say MLE. Even if the MLE was written in uppercase, you put it in lowercase, you put it in uppercase because you already start converting each and every one of them to what? Uppercase. Now, let's say somebody went and wrote VLQ. VLQ, you don't know whether it's a male or a female, but you now saw it inside your unique values. So you don't treat it. You just leave it as what? True NA character. So which means what? VLQ will be converted to NA because you don't know what it stands for, whether it is a male or it is a female. I don't know.
Sir. inside the concatenate function,
Yes.
you wrote capital letter M and capital letter May. Maybe are we not supposed to still add the small letter May and this other May that is in our console?
That is the use of this. That's the use of this place. That's the use of this place. This thing that you're looking at, string to upper, is going to convert everything inside that particular column to what? Uppercase. We are no more talking about small case, lowercase now. It's like a shortcut. Because if you don't do this, you have to now start saying lowercase male, lowercase MLE, lowercase m.
Yeah,
So this
that's
is like
what
a
I'm saying.
shortcut. So string to upper converts everything in that column to uppercase. Once it's now in uppercase, they now start treating every value as an uppercase. After you now treat everything, they now give them the proper name using this particular place. You give them a proper name. Is it clear?
Yeah.
Okay.
So okay, so I want to say something, please.
Okay.
Based on this, I think I just an let's say advice for every one of us here. I think it's better if you have a data like this to do a basic exploration, just like you mentioned earlier, and just with this unique, function that you used here now about unique line list, row data sets, so that when a person does some basic exploration, data exploration on the, checking his or her data set, he will know, okay, what to do. Not that just beginning coding, but first have to like do exploration with some basic, function, just like this unique you put, and then you see, okay, I have this, so that when you are starting, okay, this is what I have, this is how my data look like. Because just like the case now that he mentioned about maybe a person writing female and then write female or something like that, some crazy name, but you know that this is female and this is male. By seeing them, when you started, just take a note. When you started your coding, you then take that state into account without going back again. You know that okay, you have explanation. Thank you very much.
Yes, thank you very much. Very appreciate. So just like you said now, you need to understand your data because that's one thing with data cleaning. You can't just go into it blindly. You need to look at it. You know where and where and that's why initially when we started, you can see I opened the line list row and I was following it column by column, showing you where and what are we trying to solve. So the schema doesn't even have that particular use case whereby I can also show you what and what is missing, what and what you have to fix. And when you're even dealing with categorical, it's always good you even run this code. This unique line list and that particular variable you have, it's always important you run this. You can know all what you have in that particular category. Like now, I can run this for Word to also see what we are dealing with under Word. So you can see what we are dealing with under Word now. You can see Sango is coming out twice. Apata is also coming out twice with different formats. So you can see what we're having. So this unique will give you everything that is in that part, the unique values in that particular column, you'll get it using this particular unique function. So is it clear, everyone?
Yes, the unique is clear.
Okay. Yeah. So now let's go to the next one. I think we already have the concept here. So we're also trying to standardize the word now. Just like I made mention of it here. Line list first, then you first of all then now use your mutate to create a new column that will replace that former one. And that your new column is going to be what? Which is actually the name of the former one, string string. This function removes white spaces. So if you're having, for example, now ring road now, or let's say you're having, okay, no, let's say for example now you're having space after your ring road. So this particular function is going to remove that particular trailing white space for you. So next, we are going to be having a string to title. So another way of even understanding trailing white space, just any space that's appearing either at the end of a line of a text or before a line brace is called a trailing white space. So sometimes it causes problem in R. You might be seeing two words, male and male, and they're different. One is having a trailing white space because R will count it as part of the variable, a trailing, and the other one is not having a trailing white space. So that's actually important to remove them. So it's not actually the space in between the trailing white space. So the next thing that we now do after removing the trailing white space, if there are values with that, then you now the thing with the mutate is that you can fix a column iteratively inside mutate. Now I'm still going to fix that particular word. I've already replaced my initial word with this. I'm now going to replace this now again with what? By writing another, by also writing another what function in this place. String to title. So what string to title does is convert string to uppercase, lowercase, title case, or sentence case. So by default, I think by default, it converts it to sentence case by default. So string to title, word. So which means we're going to be having things like ring road, Iwo road, all of them are going to be starting with uppercase in each word. So let's run this and see what we're having. Okay. So be here. So this is it. Then I think we'll have been bust to just even run the unique. Or maybe we just leave it like this and just go through it. So you can see that most of what we're having already, they've already been changed towards sentence case. You can see all of them are already in sentence case. All of them are in sentence case. Now the next is now to recode. We don't want to be using this Iwo road, ring road. We just want to recode it to RD. So we want to recode it to RD, just RD. So inside the mutate again, you say word, recode word. So anywhere you see Iwo road, or anywhere you see Iwo road, that is where the road is complete, you replace it as what? Iwo road. And anywhere you see ring road, you replace it as what? Ring road. So this is what we just did in this place. So we already what? We recorded it. So once you run this now, I think one's open. Okay, sorry, I think I might have done a mix up. So this is actually supposed to replace anywhere you have something written as this. It will be given as this. So let me see something from you. See, run this and see. Okay. So what this actually does is that in case you have something written like this at the point of data collection, then it's going to replace it with this. In a situation whereby you have something written like this in your data, I don't know if we had this. Let me check the unique that we did earlier on. We did have something like that. Yes, we had something like that. Yes, we had it. So we had something like this. Yeah, this is it. So it's going to replace it with this. So anytime we have something like this, it's also replace it with this. So if we were to run this now, let me run this outline list and check the unique. Oh, okay. Supposed to be unique line list. So can you see it now? We're now having what? 6 unique values compared to the other ones that we had earlier on. The other one, which was so you can see the other one, which was around what? 20. So compared to that, we have already taken care of everything in this place. We're now having what? 6 unique what values. So these are you also treat that of the word. So I don't know if it's clear. So if you want to check the frequency, this is it. You can check the frequency. You can just build a frequency using the tabel function. Is it clear?
Yes.
Okay. Next, we also have that of the hospitalized. I think since we already understand the concept, we'll just go through some of these. They are just also the same thing. So you start with your line list, then you use your mutate function, then you first of all trim. This trim is to remove trailing white spaces. And before you do that, you also want to do str to lower. I think to make it easier, we can do it like this. Let me just do it like this. It's not look confusing. So, okay. So first of all, this our hospitalized variable. Okay, let me go to the raw, the line list raw. We can still use this. So this is it. So you can, okay. Oh, I've already run it. That's why. Let's just use this one. So this is the hospitalized. So you can see some are having 1. 1 means yes, 0 means no. So the person collecting the data was just recording some as 1, some as lowercase yes, some uppercase yes. So you can see all the issues that we're having here. But we want it to be in just yes and no. That's what we want it to be. So first of all, we what? We make it to be lowercase. So once it's lowercase now, all of this is going to be lowercase. All of this is going to be lowercase. So I think, let me just wait. So everything is going to be lowercase in the, where is the outcome? Okay, I think I just have to run this side again. But already affected it. So this is it. So everything is now lowercase already, as you have seen. Then the next thing we now do, we now inside the same mutate function. So then we now what? We trim. We trim for any trailing white space in case there is. So sometimes you might not even have, but it's just a good practice to always what? Do that. Then we now what? We now do our case when. So now, since all of them are already lowercase, so we now say hospital any of that particular row that is either yes or is written as y or is written as 1, make it to be yes. Any of the row, each of these row that was written as no or was written as n or was written as 0, make it to be what? No. So this is what we now have. Then any value that remains, make it to be NA. So that's what we now have in this place. So when you now run all of this, and you view your line lists, so you can see hospitalized has already been what? It's already become just only two values, yes and no. So anywhere that you see any, it was not even recorded initially, or it was a value that was what? We cannot even recognize whether it is what? Yes or no. So it's just the same procedure that we've been doing, just the former ones. It's just some little changes.
I have a question.
Yes, what's the question, please?
Okay, so in the way you wrote the code line for the sex, in the way you wrote the code line for the sex, it says sex is equals sex string into bracket sex, yeah? That's another column. Then you now said sex equals case when string to upper, then sex. But here in hospitalized, you did lower first before you trimmed it, then before you did the case when. So I don't know. Can we do it the way you did the sex or
yes, I
what
purposely
are
did it
you?
like that to show you the two different approaches. I purposely did it like that.
Okay.
You can also do that. You can, but in this case, you now remove this place. That is, I'm going to move here.
Yeah, this line now will now be in the case when.
Yes, you now bring it to here, STR to lower. You bring it here.
Okay. Yes, I get it.
So this is just
I get
another
it.
style.
Okay. I think I'll go for the first one.
Yeah. So anyone that you are comfortable with.
Thank you.
Any more questions? Any more questions? Okay. Then now we go to the outcome now. I think we have outcome and RDT result. Yes, these are the two remaining ones in terms of characters that remains. So I think all of us already understand the way it flows. So we should also understand this one. This is our outcome. This is how it looks like. You can see it's also the same thing that we're facing. So first of all, you use your mutates. This is the mutate function. Then str trim to remove. You can see this str to lower. You can also do it like this too also. It's just similar to what we just did here. I can also bring this one to also to the up, or I can even decide to just even put it in this place. So all of this is just based on one thing with using the pipe operator. Pipe operator works with your thinking. It works with the way you think you should handle the data. So that's why sometimes two people will do the same task, but different code, different way. Maybe someone's one is even longer, or the other one's is even shorter. So someone can just decide to condense everything in one place. He can understand it like that. And someone can decide to just break it down or elaborate it. So it's just also the same thing too that we're doing here. After doing that, then you now say case when. If your outcome is in any of this, make it recovered. Now we can now see, we are no more using this now because we are dealing with only one value. We are now using what? The equality sign. We are no more using this. This is used when you want to what? Compare a single value in your column with what? Multiple values. Just like we've been doing earlier on. But when you now want to compare with a single value, you now use the equality sign. This is where you now use the equality sign. So if its outcome is equals to died, then record it as what? As died. Then any other value that remains, record them as what? Missing value. So that's it for this particular part. So when you run this now, and you view our line list, you can see it has also become, can you see it now? You can see it. We are no more having it the way we were having it earlier on, where we were having some uppercase, some lowercase. So I've already handled for that. If you want to check the frequency, you can just go through, use the tabel function to check the frequency. Same thing to also do for RDT. Now, in RDT, we also use the mutate function and we create the column RDT results. Now, you look at this now that we're doing now. We have combined two. You know, in the other ones, we have been doing it column by column. You can actually combine everything into a single code. All these things that I see we did, you can just put everything in the mutate. This is just breaking it down to make it easier to digest. Because if you look at this RDT now, I've combined two of them, RDT result and source of water, inside the mutate function. So RDT result, first of all, we trim it for trailing white spaces. Then we now convert it to title. We have solved that, or we have solved that of RDT. For source of water, we also do the same thing. We fix trailing white spaces, then we convert it to what? Sentence case using the str to title. Once you run this now, and you view it, you can see RDT results. It's no more like what we have in our raw. See our RDT result here. It's no more like that now. So because the RDT is easier to clean. So you can see what we are now having. So you can see the RDT results. And if you look at also the source of water, you can also see the source of water too now has also been what fixed is in sentence case. So with this now, we're already clear or true with our character variables. We already treated all the character variables now. So the next we're not going to treat are the numeric variables. Is there any questions before I go to the numeric?
Thank you. Please, what does the trim do? I think
It removes trailing white space. This is an example of a trailing white space. Okay, let me do this. Let me see. X. Jump. X, Y, jump. Are these two the same?
No, no, they are not. No, they are not.
Good. So it was do like this. Can you see it?
Yes.
They are not the same. This is called a trailing white space.
Okay.
And it's very important you remove it because this can actually mess up your analysis of your work. So that's why it's very, very important you remove it. You might be wondering, when you're checking your data, you will be wondering that these values are the same now. Why am I getting? Because it's not easy to see. You are seeing it here because of these quotation marks. But inside your data, you will not be able to see it easily. You just think it's a regular space in the data. It can appear as something as this. It can appear somewhere here. You will not know. And you just be having problem. You will not be getting what you want. Why that's what is happening. So that's why it's very, very important you remove it. In fact, it's even easy to know. Just make sure you put use unique. Once you use unique on your column, it will fish it out for you. It's clear. It's clear, right? Okay. So now let's clean the numeric variables. So we only have one numeric variables. So, and that numeric variable is age. Now the age that was given to us, there was one awkward age there, which was 999, which was a mistake. So we need to remove that. So we also use the mutate in this place. We are replacing the age now. So we have this function called if else. It's like case when, but if else is used for simple conditions. Case when can take like 20 or 10 conditions, multiple conditions, but if else is used for just simple condition. So you already have your age variable here. This is your age variable. Where is age? Yeah, this is the age here. You can see. So, and you are seeing 146, which is not somehow not realistic. This kind and 128. So there might be some issue. Maybe it's 28 that wants to be written or 46, whereby one was mistakenly added. It's possible. So sometimes it's so good you have date of birth. You cross-check with date of birth. At times, date of birth can be correct. Why age is not correct? So in this scenario now, what we do now, we say if age is less than 0, or this sign means or, we also have and. This is and sign. We have and. So this sign means or if age is less than 0 or age is greater than 100, then give it missing value. NA real. That is for numeric. Numeric is NA real. Y character is NA character. So if the age is less than 0 or the age is greater than 100, then make it what? A real missing number, NA real. Else, just keep the age as it is. This is what it means. If age is less than 0 or age is greater than 100, then this command means then make it NA real. Else, just keep that particular age. So if the age does not satisfy this condition, leave the age as it is. Don't tamper with it. That's what it means. So when you run this and you click on this, the data has reduced. I think. Sorry, the missing values. You see the age will be missing values. So you can see those age have disappeared. Those high ages we are having, they have already disappeared. You are no more seeing them again. They have been replaced with what? Missing values. So that's it. Then you can also create groups because most of the times in health, you always want to work with categories. So you want to break your age into groups. So you can also use the mutate function, and you create a new column called age group. They now use a function called cut. Cut means you are going to cut a numeric values into a particular interval. You are going to give it breaks. So the first function it takes is your age variable, which you have in your data. Then you also have another argument called breaks inside the same cut function. These breaks, you are going to specify the breaks. So which means 0, then the next break will continue from 5. The next break will continue from 15. The next break will continue from 45. The next break will continue from 60. From 60 upwards, that's why I put INF, infinity. So 60, anything above 60 can be, can what? You can also grade anything above what? 60 into that particular group. So this breaks is like you are breaking your age group. So we are going to be having 0, then anything above 5 and above, you also have that. 15 and above, 30 and above, 45 and above, until the end, which is infinity. Then you now give it labels, because these ones are breaks. The first one is 0 to 4, because it stops before it reaches 5. The next one is 5 to 14, because it starts from 5. The next one is 15 to 29, because it starts from 15. The next one is 30 to 44, because it starts from 30. The next one is 45 to 59, because it starts from 45. The next one is 60 plus, because it starts from 60 to infinity. So then we have this right. So I think I might need to check for this right. So let me see. Okay. So it's just a way of closing that particular interval. So if the interval should be closed on the right or on the left. So if you say right is equal to false, it means you should not close it on the right. So on the right means that anything can enter above 60, because you can decide to close it in the sense that you have already put a mark that this particular value is 60 to this. So anything above that, it will become missing value. So that's where we have the right is equal to false. So when you run this now, and you open your line lists, you can see our new age group. The ones that were having NA, they're going to be having NA. So you can see our new age group here. This is our age group now that we're having. This is our age group. So I've already grouped it now. So we might end up not even using the numeric, we'll be using the categorical for the analysis. I don't know if this part is clear. Is it clear?
No, sir, it's not too clear, sir.
Okay, I should come again.
Yes, sir.
Okay. So we have our age already, which is a numeric. And we want to classify it into what categories. So this particular value, this particular function is called cut. That's the work. I think I just entered the help now. Let me see it. So this is it. It divides the range of x into intervals. It divides the range. If you have a range of values, it divides it into intervals. It's like you are breaking a value into intervals. So this, you now have to specify the breaks. The breaks is the point at which the next is going. It's just like you have a number, you have a line. You are now creating a partition. Okay, start at 0. When it goes to 5, you draw a line that this place is 5. You break the line. When you go to 15, you break it. When you go to 30, you break it. When you go to 45, you break it. You go to 60, you break it. So from 60, no more breaking. So that means you have already divided the line into how many equal parts? You have divided into what? 6. You have started from 0, then 5, then 15, then 30, then 45, then 60. So you have what? 6 parts. Out of those 6, your age must fall into one of them. The first is 0 to 4. So you already said 0 to 4. Then your next break is 5. So if you have a value 5, you cannot enter 0 to 4. It has to now go to what? 5 to 14. Your next break is now 15. So any value between 15 and 29 will enter what? 15 and 29. Once it's now 30 something, you have to now take it to what? 30 to 44. So it's like you are grouping your ages. You are grouping them. You can group it into 10. It depends on the way you like it. Or maybe you have a standard that you want to use. You can group it into 10, you can group it into 3, you can group it into 20. it just depends on what you give. If you want to group it into 10 now, I can just decide to say 70, say 65, 70, 75, 80. That means I need to add something in this place now. I'll now come and add, I can say 60 to 69. Okay, I think I would have just copied this for me. Okay, so I can just say 60 to 69. Let me call it another age group 2. 60 to 69, then 65. Okay, 60 to 64. So 60 to 64, then 65 to 69. Then we have 70 to 75. Then we 74, sorry. Then we have 75 to 75 plus. Okay, 75 to 80 or 79. Then we now have 80 plus. So I think if we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 now. This is now 10. When I run this, okay. Okay, I think, okay, I've not put this infinity here. So infinity allows you to be able to cover any number above 80. So when I run this, I go back to data. Now, you can now see that we are having, can you see age group 2 now? So let's go to the ones that are having 60 plus. Those ones that are having 60 plus will be in, you can see it now. I've already grouped this. So this is another what? More expressive group. This one is having 10. This one is now having what? This one is having 6. Okay. I think, where did I put it? Okay, I think I might have put it up. Where is it? Okay, put it in the wrong place. Okay. So this one is having 6, this one is having 10. So you're just breaking the numbers into various groups. I don't know if it's clear, sir.
Maybe let me give a suggestion. Maybe can we view the column for the age and the column for the age group side by side by selecting the two, just for them to view it so that they will be able to understand maybe the break, how you broke it down.
Okay.
The last line, right, equals false. What does that do?
You see?
The last line in our code, right, equals false.
Yes, that's what I'm telling you,
that
that it's a way of closing the boundary. Yeah. Now, by default, right is equals to true. When right is equals to true, it means that you must have an interval for that particular, that means you must have an interval for this place. That means, let's say 80 to another value. But when you say right is equals to false, it means any value above 80. That means this place can cover, this particular label, it can cover any value, whether it is 1,000. As far as it's above 80, it's going to fall into this particular category. So it's just more or less like closing, you're opening that particular right. But that's why they say right is equal to false. It's like you're opening that particular boundary on the right, because your number is increasing on the right-hand side of a number line. Your number is increasing. So it's like you're opening that particular place to accommodate any big number, provided that is above that last cut. So you are giving room for that particular big number. So you are not saying if you have 1,000, then 1,000 now come and be recorded as NA, or 1,000 might not even be given a group. So that's what he's just trying to mention. I don't know if it's clear.
Yes, sir. Thank you.
Okay. So let me just H group 2. So can you see it now? This is our age. This is our age group, and this is our age group 2. Can you see the difference between two of them? So one of them is having 10 groups. This one is having 10 groups. This one is having 6. If you go to the bigger values now, like here, you can see it now. You can see that this one is having 60 plus, this one is having 65 plus 69. I don't know if it's clear. Is it clear?
Yes, sir.
Okay. So I think the last part now that we're having is for the dates. So if you look at our dates now, if you go to our dates, these are our dates. So you can see our date is not uniform, the formatting. Some are having the month name, some are having the month in numbers, so it's not actually uniform. So this is it. So we want to make it uniform, and it's very easy. So these are things that normally you just have to be going through support, but you already have a function that in just some few lines is going to be easy for you to just do that. So you have line lists and mutate to again, because we want to replace those particular dates. So date onset is the first one. This is just the function you need, pass date time. This will convert any format for you into a standard format. Then we have what quiet is equals to true. So this quiet is just true, is just to avoid warnings that is going to be showing why running this particular code. So you have date onsets, and you have this argument orders is equals to this. This orders means that it's going to go through any of this format. You can have year, month, day, or day, month, year, or month, day, year. These are most of the common formats that date usually comes in. So it's going to what? Convert this format into a standard format as dates. It's not going to make it as dates. It's not going to become day, month, year. Standard. Therefore, date of report, it will also do the same thing. You have this particular function. All of these are inside mutates. You are creating a new column using in this place. You are also creating a new column in this place. So when you run all of this and you view your line list, you can see the data has been standardized now into a single format. So the thing works like magic, but you just need to understand the function. This is the function pass date time. So no matter the kind of format your date was written as, because the date was even written as characters, it's going to change it for you. So there are some complex ways in situations whereby you use it. So you can just read more on this particular documentation to understand it better. So this, by default, this is the argument here. By default, we have the orders in which this particular date will comes in. It's going to look at that particular date, each row, to look at which format is it coming as. So, and like I told you, the quiet is equal to true. All those progress messages and warnings, or if there's an errors, they're not going to be showing to you while doing it. So it's just very simple. Just, you can even use this self-directly, just your dates onset, which is your column name that you want to replace, then the others, then also quiet is equal to true. Then you are able to get your answer. You are going to get a clean date, and you are done with the dates. So they now say we cannot have a situation whereby some days will fail to pass. Some days fail to pass, meaning we have some stubborn dates that still refuse to convert into a standard format. So you can check for them. So, and most of them will come out as NA. So if you run this now, you can see we have some dates that fail to pass. There are 9. These are them. 0266. Let's even check our line list row and see them. 0266. And we have 0266 here. 0032. So 00066. Okay, let me just do this. So, date of onset. So date of onset did not pass. So let me check the line list raw and see what was happening. Okay. Line list raw is not coming out. Okay, line list raw is using case ID. It's using case ID. So this is one of the issues I mentioned. Once it's having space, it becomes difficult for it to filter. That's most of the times you need to remove the space. So I'm trying to filter for it now, but it's not coming out. So I think I might need to run this again and see. Line list raw. So date onset was actually even NA initially. So it seems some dates were not recorded. That's why you can see some of these failed to pass. They were not actually recorded. So I think that was the challenge that we are having, why some dates failed to pass, and you can see there are only 9 of them. So there are actually 9. So these are the 9. So we can decide to remove those 9 if we don't want to use them, since the amount are actually negligible. So in this place now, I'm filtering the data. So as dates, now we're ignoring all these ones. So any date that is less than this as dates is a way of making a particular value to be in date format as date this. So you are making this particular character you wrote into a date so that you cannot compare, because if you make it as a character without putting as date now, you're going to get an error. So you need to make it into a date time format, because if you check the type of data that you're having, you are dealing with line lists, then date onsets or date of reports. You can see it's a date type. It's not just a normal character. It's actually a date type. So when you're comparing it with a value, that value also needs to be of a date type. So that's when you can now compare them. If not, you're going to be having what? Errors. So filter the dates that are less than this, or the dates that are more than this day. Then select case ID, date onset, and date of report. So I'm going to run this. This one, I'm just filtering in this place. So these are the values. These are the dates that are less than this place, this value. That is 1st of January 2026 and greater than, they say date that is less than this or more than this. So you can see them here. 2026, 05, 2013. So all of them, you can see it's just like between January to August. It's like you are selecting between January to August. So now we are going to be dropping rows with impossible / missing dates and fix the reporting date if it is earlier than onset date. Okay, so we did something here. Let me, another more explanation I was supposed to give in this place. We have date of onset and we have date of report. So that's what we are trying to fix in this place. Date of onset and date of report. So date of report is actually supposed to be more than, okay, date of onset is when is actually the disease actually shows, then date when it was reported. So date of report should be more than the date of onset. But in some cases, there might be mistake whereby the date of onset might be more than the date of report. Because if date of report is January and date of onset was March, then one need to fix. That's what they're trying to fix in this place. So fix the reporting date if it is earlier than onset. So the reporting is not supposed to be earlier than onset. So the first thing we do now is to filter. We use the filter function. We look for we remove NA first. That's what this exclamation mark means. Sorry, we check for NA. If we remove this exclamation mark, it means we are filtering for what? NA. If they say is.NA, that means dates that are having missing, NA. But if we now put exclamation mark, it means give me only dates that are not missing. Not, is that exclamation mark in R means not NA. So filter for date of onset. So I think we need to run this separately. So we'll just see what we have. So date of onset. So this is it. These are the values. So we are only filtering those that what? The date of onset is greater than or equals to this particular day. And the date of onset is less than this particular day. So we're excluding anyone that doesn't fall into this particular place. And if you look at it, we're having 296 data. So because we don't want date of onset to be late compared to date of reporting. So any date of onset is between this particular range is what we're actually filtering for. And after doing that, then you now also run the mutate function. You now say date of reports. If date of, that's if else that we used earlier on. If date of report is less than date of onset, that is date of report if it is earlier compared to date of onset. Because date of onset is supposed to be earlier compared to date of report. Or it is missing. Then record that particular date of onset. So if date of report is less than the date of onset, or it is actually missing, then leave it as date of onset, or you want to make it as date of report. So if this condition is satisfied, then you should leave it as date of onset. But if it is not satisfied, you what? You leave it as what? Date of what? Report. That means there was a mistake. That means the date of onset, if the date of report is earlier than the date of onset, it means that that particular date of report was supposed to actually be the value of the date of the onset. Because date of report cannot be earlier than date of onset. So this is what we are just trying to fix in this place. So we are just trying to ensure that date of report is not earlier than date of onset. So if the date of report is earlier than date of onset, or it is actually missing, so just make the date of onset to become the what? The date of report. So that means date of onset and date of report are going to be the same thing. So that's what I'm just trying to do in this particular place. Then we also have reporting delay. Reporting delay is the number of days between date of report and date of onset, where we're using the mutate to also create another variable. So when you run all of this now, and you open the line lists, so you can see reporting delay here. Anywhere you see 0, it means date of onset and date of report are the same. Anywhere you see 0. Anywhere you see 0, it means date of onset and date of report are the same. I don't know if this part is clear. Or I should come again. Hello?
It's okay. It's okay. You can continue.
Okay. Now, we have already cleaned all what we need in our data. So then the next is now to just look at the summary of what we have. So this is our delay. This is the summary of it. Then you can also use just this function to look at your data now. So you can now see our data now, though we have missing in the age. So this is it. These are our data. We're just looking at the glimpse. It's going to be different from what we did earlier on because I've done a lot of cleaning already. We still have missing values. Why I not cover missing values? Because missing values is a very it's also another topic on its own. It involves a lot of procedures. So that's why missing value treatment is also part of the data cleaning, but it was not covered because it's also comprehensive on its own. There are a lot of techniques and procedures to do before you even start talking of imputing and missing data. But some of the other minor data cleaning, we already take care of it, which is all these names, dates, issues, and things like that. So your last step is to now write down. This is what we will continue from tomorrow, God's willing. We are going to use the right CSV to save our data. Just like the way you loaded your data, you're also going to save it just like that way. It's just that in this time around now, you have to get your variable, your data variable, because your data is already in a variable. So you need to declare it first. Then you also declare the parts where you want to save it, which is what's inside the data folder. Once you declare these two, then you can just run the right CSV. Once you run it, if I check my files under data, you can see it here. AWD line list clean in class CSV. You can see date modified 1:01 p.m. That was today, July 11th. So this is how you can clean your data. I don't know if it's clear. Are we good?
Just repeat what you said last.
Excuse me, sir.
Yes.
So I want to ask a few questions.
Yes.
From when you were doing the age group, so I
Yes.
noticed that you use the cut function, and I also know that you can use the age categories function. So what's the difference between using the cut and the age categories function for creating age groups? And the other question is it possible, instead of searching for the other time you're searching for the IDs, some IDs, is it possible to arrange the IDs in ascending or descending order so that it makes it easier to locate any particular information? Thank you.
Sorry, please come again with your question. Sorry, please.
Okay, so my first question.
Okay.
When you were creating the ages into like different age groups, you used the cut function.
Okay.
So, and I know that another function that can be used is age categories function for creating age groups. So I'm asking that, is there any difference in using the cut function and the age categories function for
The age category
creating?
function in which package? Let me see.
I can't even remember, but I know that. Let me come in.
I've
I
not
will
come
have to.
across it, right? I've not come across it, so that's what I'm asking. Yes.
I don't really, I can't really say what package it is right now, but I know that in a previous training we used age categories function.
Well, from the name service, maybe it might even be easier than using the cut function. So if it's actually easier, then one can actually use. You can actually get the package. We'll have even used it. Age category option.
I think I have to check my notes. I can't really remember currently. And then the other question is it possible to arrange the case IDs in ascending or descending order so it makes it easier to locate whatever information one is looking for?
Is it possible to what?
Arrange the case IDs.
Yes.
Because I think the other time you were searching for a particular date.
Yes,
or was
yes,
it case ID? So I was going to ask if it can be arranged in a descending or ascending order to make it easier to locate rather than
Yes,
just scrolling.
there's a function in the deep layer. I'm also trying to recall it now. I think it's this function. Let me see it. Descending. I think it's descending. Let me see. Let me go to the end and see. We descend line lists. Then descend by case ID.
No.
Then let me see.
No, it's arrange.
Oh, okay. Error in view. What's happening? Okay. What's the problem?
Wow. Please just go let me finish the class, okay?
I'm trying to see. I think it's this function now. Yeah, it's the one. It's the one. So I don't know why it's coming up.
Oh, okay. Please let me finish the class, okay?
Okay, let me see.
Hello? Hello?
Think.
Sorry, can you hear me?
Yes,
Ridwan?
arrange. Arrange, yes.
Arrange,
Yeah,
exactly.
yes.
Sorry,
That's
I
what I was
wanted
trying
to
to
be
look for.
okay.
That's what I was trying to
Yeah,
look
then
for.
you can now use the descending order inside of that function. Yeah.
Yes, ID. Like this now.
Yeah. Yeah. Let's try that. I think yeah.
Okay. I think now we are
But it's
supposed.
not
Yeah, it's in
completely
descending order and it's also been
number.
ascending order.
Okay. Okay,
There
you
is
can try that.
there is one for ascending, I think. Or is it based on an
By
argument?
default, no, by default, it's ascending order. You can check the documentation, but the case ID is not just numbers. It's not just numbers.
Let's try it like this then.
Okay.
Yes. So I think this is it. I think this is what you're referring to. Yeah?
Yes, sir. Yes, sir.
So this is how you do it. So there is this function arrange. It's a part of dplyr. So if you want it in ascending order, you just use arrange. But if you want it in descending order, you need to specify that descending. This descending function I did earlier, so you need to specify it if you want it to be in descending order. So this is the arrange function. So you can use it to arrange your data from smallest to the. So okay, where is it, sir? Which one?
And I can see that on the
Okay,
chat,
so
the package is Epikits package.
exactly, yes. I don't want to make it that.
Okay, for the
So
age categories, right?
yes.
Yes, it's Epic.
Yes.
It's true. Whom I just record now.
So okay. So I think the most important thing is no matter the package or the function you're using, just get the job done. That's all. That's all.
Yeah, that's just it.
And
Somebody might find
you
the age
should
categories
know,
easier.
exactly. So, and you should know what you're expecting from that function. So you should be able to validate, am I getting the right answer from the right output from the package I'm using or not? Because in certain situations, it might not be the tool you use during a certain project that will be kind of relatable to the one that you're working on now. So you need to be careful. So a lot of projects might be considering statistical outputs and all this stuff. So just be careful when you're using this a certain tool.
So I don't know if I have something on my slide I've not covered. Let me just check.
Okay, it's past one already.
Yes. Yeah. So I think we are done. So I think tomorrow, God's willing, we'll be looking at the attack rates, epidemic curves, and also tables.
Okay. So please be on time. Be here tomorrow by God's grace, and we'll really appreciate you being on time, please. So I can
Remind them
cover
of
a
the time,
lot.
please.
So the time is 1:30 p.m. tomorrow, 1:30 p.m. to 3:30 p.m. So please, I think that covers everybody, irrespective of you want to pray, you're going to church, or you want to pray in the afternoon. I think we are covered. So we'll see you tomorrow. Thank you so much, everybody, and thank you so much, Ridwan. We had a really fun time. I think everybody got what they want, and I can see some feedbacks are here. Yeah. The script I shared, okay, that brings me back to I will need to get your feedback. So, and that will serve as the attendance sheet somehow. So for us to be able to share with you, because we have almost 260 something, I think 64, 65 people that registered for this event. And I think we're getting something like 30% of it. So we don't want to just be sharing information. We appreciate your time here for you to commit to coming and showing up till the end. Then that's something we have to reward. So kindly fill in the feedback and then we'll share the code and the recordings with you. So I believe we'll be able to share that before the end of today, before 5 p.m. I should be able to send that. So thank you, everybody.
Thank you, everyone.
Thank you.
Have a nice.
So thank you, Ridwan. Thank you. Bye. Bye-bye, everybody.